Okay, guys. Good morning. I think we might get started here. You're all very welcome. So I think just obviously before we get started, I just want to say a quick word maybe about paper one. I don't want to spend too much time on paper one, obviously because we've a lot to do this morning and there's nothing we can do about it now. But certainly my feeling about paper one was that it was quite an unusual, quite a tricky paper. What makes it kind of unusual from my perspective is that people are kind of split right down the middle. When I had a look at the paper myself on Friday, my gut feeling when I looked at it was that I thought the short questions were a little bit more straightforward. Because I thought he was asking you, telling you very directly what you needed to do here. The trickier parts at the end of some of the short questions, he actually told you how to do. And I thought the long question may be a bit trickier because they were very wordy. Okay, there was an awful lot of text in there you had to sift through before you kind of worked out what the maths were, all right? So I've been hearing from kind of students, I've been chatting to students all weekend, and kind of almost 50% will say, yes, the difficulty for me was the long questions. They were very wordy, I wasn't sure what he wanted me to do. I know the maths were easy, but the long questions are the hard part, the short questions were fine. 50% of people the other way around said, nope, the short questions were undoable. The maths in the long question was much easier. I saw through that. I found that the long questions quite straightforward and the short questions very, very tough, right? So it was a very unusual paper in that I've never seen one of that before where people were split right down the middle between where they thought the difficulty was and whether it was a short or long questions, all right? So right down the center. I think probably in spite of your best intentions, you guys probably spent Friday and most of yesterday looking at reactions to the paper on social media, which is never a good idea. Right? Because what you're hearing from there is maybe you've heard from maybe about 100 people, maybe the people in your year and a few people on social media. Remember, 20,000 people did the same paper you did, and most of those you haven't heard from, right? So sitting there, I mean, I won't ask for a show of hands how many of you did that, spent the last 5 minutes of the exam on the back page adding up the number of marks you think you got on each question to see, oh my God, did I even scrape my H3 here? Is it even possible? There's no value in that at all. That from experience, probably 7 out of 10 people will underestimate the grade they got on their paper in paper one, simply because you guys have no idea what's going on with the marking scheme. The post-marking adjustment, the adjustments to the marking scheme, that all has to happen and you guys aren't aware of that. There's no value in trying to work out what you think you got on Friday because you will almost certainly underestimate that. And what that does is it now puts you under pressure tomorrow. You're kind of saying, look, I have to leave no crumbs tomorrow morning or I'm in serious trouble. I'll be working at Eddie Rockets this time next year. So you really don't want to go down that route of kind of saying, putting myself under huge pressure, that paper one didn't go well, therefore I need a stellar performance tomorrow or I'm in serious trouble. Okay, that's not the way this works at all. All right? All you're going to do is going to give tomorrow the same shot you gave on Friday and just see where it pans out. Remember that no matter how difficult or how straightforward a paper is, the H1 students still get their H1s, the H2 students still get their H2s. The marking scheme will make all that come out in the wash. It's hard to see that now, okay, but that's the reality of it. So obviously with paper two this morning, you're on the screen there, we've got the 6 big hitters there from paper 2. Trigonometry, obviously, to begin with. Probability and statistics, and the slightly smaller ones, the circle, the line, and geometry. You can obviously get a little bit of area and volume brought in there, which will normally be tested with trigonometry. So area and volume can appear on paper 1, as we've said before, with calculus. It didn't make an appearance really on Friday. So area and volume might make an appearance along with trigonometry as we have a look at this morning. Right? So I'm going to kind of touch base with all of these here. Again, as I said on Thursday, and you were with me on Thursday, I'm not kind of making predictions here about what's going to make an appearance. All we're doing here is playing the odds. You know, what's most likely to make an appearance. So for example, in the first question here, there was no trig function anywhere on paper 1. Which means that I think it's very probable we'll see a trig function on the paper tomorrow, okay, which we'll have a look at. So we'll kind of work our way through a few of these. So this is not kind of based on prediction. It's just here's the kind of stuff the examiner tests every year and we haven't seen yet. All right, so we'll start off with the trigonometry. I'm going to do the trigonometry first, kind of a couple of questions on trig, things to point out. I'm then going to maybe do the statistics and probability, and then I'll wind up by having a look at the circle, the line, and the geometry. And I will talk to you over the course of the morning about things like proofs and constructions. You know, what might or might not make an appearance there. But I'll give you the same advice I kind of gave on Thursday. I'm not sure what the value is now in trying to spend today learning lots of new maths. If you haven't learned something before, I think you're much better off now just trying to consolidate and nail down and make sure you're confident on the stuff you've already learned rather than frantically trying to learn new stuff. Okay? So if you look at question 1 there on page 4, okay, so just to begin with. Okay? So question 1 then on page 4. Sorry. So this is a trig function question. Right? Now, we didn't see a trig function on paper 1, so it's always, the last kind of 7 years in a row, he's asked a trig function every single year. He's only varied which paper he asks it on. So last year was asked as part of a long question on paper 1, so I think it's likely, it's not a guarantee, so it's not a banker, but for me it's very likely we'll see a trig graph question on paper 2 tomorrow, right? So just kind of put the key bits with trig functions back on your radar. Remember, the first thing here, that when you read the question, it says a patient's blood pressure varies sinusoidally. Remember, that word sinusoidal means it just forms a repeating wave shape. It doesn't necessarily mean it's a sine graph, so both the sine and cosine functions are sinusoidal. They form a repeating wave shape, okay? So vary sinusoidally with time in a manner that can be approximately modeled by the following function. P of t is k times cosine 25 pi over 9t plus 108. And notice, you're told here that it's in radians. So straight away in your exam, switch your calculator into radian mode. The reason why we normally do the trig functions in radians is because what he can do on paper 2, even though it's paper 2, he can ask you to do some calculus. He can ask you to find a rate. Or he can ask you to do integration to do an average value. I'm going to show you both of those now in a second, okay? And remember, the shortcuts for doing differentiation integration from your formula booklet only apply when things are in radians. So he will always make that clear. So would you see radians, I'd straight away switch my calculator to radian mode so I don't forget, okay? So it says where P of t represents the blood pressure in millimeters of mercury, t seconds. So the units are given here. So P is in millimeters of mercury and t is in seconds. Okay, so you've got your units marked out there. So after measurement begins, and K is a constant to be found. Now, any of you kind of been doing this with me all year, you'll know what my standard advice is with a trig graph. What I do first, before I start reading the questions, is I sketch it. Let me see if I can sketch it, because very often if I sketch the graph, I'm actually answering questions already without even realizing it. And I'm going to sketch it right here where the examiner can see what I'm doing. Don't put it in the margin somewhere. Put it in the box here where the examiner can see it. Somebody asked me that at the last thing we did. If I write outside the box, will the examiner correct it? The examiners are not told to ignore stuff that's not inside the boxes. Just remember, the boxes that are provided here, the SEC will guarantee anything you write inside the box will scan well enough to be marked. If you write something outside the box, it may not scan well enough to be readable, so the examiner might not see it. So if you want him to see something, put it in one of the boxes to make sure he gets to see it. All right? So remember, we're dealing here with you can see it's a cosine graph here. Okay? So if I'm dealing with a cosine graph here, all right, just a very rough sketch of a cosine graph. I mean, the cosine starts at the top, goes down and then back up like that. That's the basic shape of a cosine graph. Okay, it's a positive cosine graph. How do I know it's a positive cosine graph? Well, look, we're told that we've got this value k here, and we're told that k is a natural number. Okay, so it's a positive whole number. So k is a natural number. So k is positive. So it's going to be a positive cosine graph like that. That's the basic shape. Now, the three magic numbers. Okay, remember, in any trig function, the constant, the number by itself on the end there, that's always your center line. So the center line for this graph here is 108. Right, that's the center line there. Right, so I'll fill that in first. Secondly then, the number that's in front of the word cosine or sine, in this case the k, that's the amplitude. That's how far above and below the center line your graph's going to go. So the graph's going to go up by k and down by k. Right, so if I knew, for example, that k was 20, it would go up by 20 and down by 20, so I could fill in the top and bottom values here. So all I can say here is that this number up here is going to be 108 plus k, okay? And the bottom value down there, the lower value will be 108 minus k. Okay, so k is the amplitude. It's how far above and below the center line your graph will go, right? Finally then, this number here, the number in front of the t, that will tell you what the period of the graph is. How long it takes before that pattern starts repeating itself. And the simple rule to remember there is, if we're finding the period, a full circle divided by this number here will give you the period. Okay, so remember that a full circle is going to be 2 pi because we're working in radians here. So if I work out what that is, so 2 pi divided by 25 pi over 9. So take a full circle, 2 pi divided by 25 pi over 9. That will give you the period. That comes out as 0.72. Okay? So that's 0.72 there so it repeats every 0.72 seconds. Now that's the maths you need for working with trig functions. The basic shape of a graph and then what those three numbers do. The constant, the number by itself is your center line. The number in front of the word sine or cosine is the amplitude. It's how far above and below that center line the graph will go. And if you take a full circle, 2 pi, and divide it by the number that's in front of the letter, that will tell you what the period is, right? So the period here is 0.72, all right? So you can see now, having done that, I've actually done all the spade work now for part 1 and part 2. All the thought is done already. Look what we're told here in part 1. It says the patient's maximum systolic blood pressure is 135. Find the value of k. Well, look at your sketch. You've got that the maximum here is 108 plus k. That has to equal 135. Job done. Yeah? So we can just write that down now. So 108 plus k equals 135. So subtract the 108. you get k is 27. There we go. Some very easy marks to get me off the road. And now what that means, remember, is that k is a constant, so for the rest of the question, k is 27. So we now know that the formula is 27 times cosine 25 pi over 9t plus 108, right? And you can see here, if k is 27, okay, that means this is 135. And then if I subtract the 27 down here, 108 minus 27, that gives me 81, right? Which, sports fans, you'll notice, is your answer to part 2. See what it says in part 2? So part 2, it says, hence or otherwise, find the patient's minimum blood pressure. So the minimum now I can just write down without any further explanation, 81. And make sure you put your units in. It's 81 millimeters of mercury. You'll lose a mark if you leave out the units. Right, so 81 millimeters of mercury. Now, notice what he said there as well, hence or otherwise. That again, in my head, when I see the word maximum or minimum, I'd be thinking calculus. Perfectly fine. So if you kind of said, look, to find the maximum, I find the derivative and put it equal to 0, you can absolutely do that for full marks, okay? But just if you're asked to find the maximum or minimum of a trig graph like this, it's easier if you can sketch the function, because your graph is the workings, and you can just write your answer out. It's easier than trying to do some calculus, okay? That's part 1 and part 2. So part 3 then. It says, find the patient's blood pressure 0.15 seconds after measurement begins. So find the patient's blood pressure 0.15 seconds after measurement begins. Now, I did say this on Thursday. We're talking about applications of functions. Very often what will happen on an application of functions question, your first bit will just be throw a number to the formula and get an answer. Let's get your score moving. Let's give you an easy bit to get going. So that 0.15 seconds, that's a value for t. So I just have to sub that into my formula. So I get 27 times cosine 25 pi over 9 by 0.15 plus 108. And I'll put that into my calculator. Now, what I would strongly recommend tomorrow if you get one of these is write that down. Don't just put the answer down. If you just put the answer down and it's correct, you will get all 5 marks. But let's say, for example, you forgot to put your calculator into radian mode, it's in degree mode. You'll have written an answer down which is incorrect with no supporting work, you'll get 0. Right? So if I write that down, I get the wrong answer. My examiner says, okay, he or she knows what they're doing. They've done the question correct, maybe their calculator was in the wrong mode here, all right? So they'll give you the high part, they'll give you 3 out of 5. If you don't write that down and just put the wrong answer down, you'll get nothing, you'll get 0. So that comes out of it, it's about 114.9, let's call that 115. And again, put the units in, millimeters of mercury, you'll lose a mark if you leave out the units. 5 relatively easy marks to get us up and running, right? Then part 4 is the other one I'd expect then. Then what you want to do normally is put a number in on the left-hand side and solve the equation you end up with. So you can see here in part 4 it says, each cycle of the function represents a single cardiac cycle, a single heartbeat. For how long during each cardiac cycle is the patient's blood pressure less than 90 millimeters of mercury? Okay, so again, look at the number given the question. It's 90 millimeters of mercury. That's a value for P. The same way the previous one, I put t equal to 0.15 because seconds told me it was a value for t. This is a value for p. So if nothing else, I'll just put that in. Okay, so I'll just write that in. So I'll just write down my equation. So it's going to be 90 is equal to 27 times cosine 25 pi over 9 t plus 108. And yes, you guessed it, sports fans, there's your low partial. There's your 3 or 4 to 10. I've shown the examiner I know what he wants me to do. So even if I'm not sure how to solve the equation, I'm not getting 0. Okay? So I've set the equation up like that, and now I just want to try and solve the equation I end up with. All right? So if I subtract the 108 from both sides first, I'll get minus 18 is equal to 27 times cosine 25 pi over 9 t. I guess kind of one thing that's maybe just worth pointing out here in this question, let's say you got the 27 wrong in part 1. You've all done that, haven't you? You've done the long question where you got the very first answer wrong, and that means every answer's wrong from that point onwards, and you think you suck. Okay, well, you do, but not very badly, all right? I mean, the thing is that you don't get penalized again for that same mistake again. So if your answer to part 2 and part 3 are correct using your value of k, you get full marks. So don't worry if you get the first answer wrong, then you don't carry the error and keep getting punished for it. If your answer for k is incorrect, but you've done parts 2 and 3 correct using your value for k, you don't lose any further marks, okay? You don't keep on getting penalized. So if we divide across by 27 then, I'm going to get minus 18 over 27 is equal to cosine 25 pi over 9 t. There we go. You don't need to simplify that number on the left-hand side. It's going into your calculator now anyway. All right, and now remove the word cosine by using inverse cosine. Now, you can at this stage treat that like another trig equation. We're going to see one of those in question 3 now in a second, where you use the cast circle or your equivalent. I tend not to. If I'm just doing one of these here, I just want to go and find a value for t, show the full sequence of steps, because if I just get a value for t here, but can't find the other answer, there are 2, I know I'm going to get the high partial credit. Okay, we're going to have those miraculous HPCs that we're all surviving on these days, all right? So if you can just get the value for t, all right, I've got the highest partial credit. I'm then only playing for like 2 or 3 marks to try and find the other value. So just get the t by itself. Take the inverse cosine of both sides. So the inverse cosine of minus 18 over 27, you can leave it like that, will equal 25 pi over 9t. And if you put that into your calculator, that number comes out, it's round about 2.3. Like 2.300 something. So that number is about 2.3. And then finally divide across by this number here to get the t by itself. So if I divide across by 25 pi over 9, I get that t is around about 0.263 or thereabouts seconds. Okay, so I'm just solving the equation. Now, I haven't actually answered the question yet, but I'm solving the equation. Now, that's 8 marks out of 10 all day long. Because whoever's doing that says, okay, this student knows how to solve a trig equation. Okay, they've got the right answer, right? Now, just look at your sketch if I want to kind of finish the question. All right, so I've got 0.263. So if we just look at the graph here, we're asked for how long during each cardiac cycle is the blood pressure below 90. So if I look at my sketch here, see the way 90 is here somewhere. It's in between 108 and 81. So if I go across from there, there's the 2 times, that one there and that one there. There's the 2 times during a cardiac cycle where the blood pressure is 90 millimeters of mercury. I just found the first one there, which is 0.263, right? That first one there is the one I found, 0.263. Do you see how you can find the second one? Because remember, the graph is symmetrical. The right and left-hand sides are mirror images of one another. So if the first number is 0.263 in from the left-hand side, the second one's going to be 0.263 in from the right-hand side. Okay, and notice the right-hand side here is 0.72. So if I come back 0.263 from 0.72, I've got the second answer. And remember, I'm only kind of playing for those last couple of marks here, all right? So the second answer then is going to be like 0.72, which is the end of the graph. Okay, 0.72, take away 0.263. That'll give me my second answer there, which is about 0.457. So there's the 2 times in a cardiac cycle when the blood pressure is equal to 90. And you see in your graph, and it's in between those 2 values, it's below 90. So just subtract one from the other there, and you've got the length of time it's in there. But those last two calculators, I'm only playing for a couple of marks there. So the time taken there, it's going to be 0.457 seconds. Take away 0.263. Which comes out around about 0.19 seconds. It says to 2 decimal places, so I'll give my final answer to 2 decimal places there. Again, if I don't round to 2 decimal places or I leave the units out, that's a 1 mark penalty. He doesn't penalise both. So you won't lose a mark for rounding and a mark for units. So again, if you get the trig graph, I'd be expecting to see both of those. The question where you just throw a number in and pop it into your calculator, the one where you solve the equation you end up with, right? Now, just to finish off the question, those 2 bits there, just to be prepped for, he can and has already done that. Ask calculus or integration on paper 2 as part of a question of this type. So again, on Thursday, I did speak about that, those 2 buzzwords. The buzzword there in part 5, find the rate. Rate means derivative. Okay, and in part 6 there, find the average blood pressure. Average means integral. And again, as I said on Thursday, if I see those words, I'm going to write in beside them what they mean. Because normally what will happen there, remember, in the marking scheme, it's kind of a little bit rough, but in a typical marking scheme for Leaving Cert, all right, if you show the examiner, I know what you wanted me to do, I just don't have a Scooby how to do it, you get low partial. If you show them, I know what you want me to do, and I had a stab at doing it, you'll get the high partial. And if you show them, I know what you wanted me to do, and I did it, I get full marks. So if you write in the word derivative beside rate, or you write in the word integral here, you're showing the examiner, I know what you want me to do. You want me to integrate that, just I haven't a clue how to, all right? But I'm telling you it's integration questions, so I'm going to get my low partial. All right? It'll normally say the marking scheme, any attempt at differentiation or indicating differentiation is necessary. Okay, we'll get the low partial. So this is a differential calculus question. We're asked to find the rate. Now, I think just the solutions for these questions are up on the platform. These notes are up on the Grind 360 platform with the solutions attached. I think there's a typo in part 5 and 6 solutions that I've just, the number is 29/5 rather than 25/9. Okay, so I just kind of pointed out to you that there is, I think that the numbers kind of just jumbled up slightly. The rest of it's correct, just I wanted to point that out to you. All right, so rate here, it means finding the derivative. Now, to find a derivative, we talked about this on Thursday night anyway. Your function, remember, is this, that P of t is 27 times cosine 25 pi over 9 t plus 108. So if you want to find the derivative, P prime of t, or dp, dt, whatever you want to call that, nobody cares, all right? Remember that when I'm doing a trig function, as I mentioned on Thursday, it's number function bracket. Any of you kind of taken any calculus class with me this year will know that that's the approach I take for any of these functions here, number function bracket. The number in front, the 27, the function, cosine, and then the bracket. Right? Number function bracket. So the number in front just stays put. If there's a number in front of your function, in this case 27, just leave it there. Okay, so the 27 stays where it is. Okay? So if there's a number in front of the function, just leave it there, it stays put. Function. What does cosine turn into? Well, remember, because I'm differentiating here, I go to page 25 of my formula booklet. So page 25 is where the calculus shortcuts are, all right, so to find derivatives. And page 25 will tell you when you differentiate cosine, it becomes minus sine. So cosine turns to minus sine, so I get minus sine 25 pi over 9t, right? That's the function done. And then bracket, you multiply by the derivative of the bracket. So if I differentiate 25 pi over 9t, I just get the number 25 pi over 9. And those last two together, kind of that function bracket, that's the chain rule. Yeah, doing the function first and then doing the bracket, all right? So number function bracket, the number, if there is one in front, stays put. The function, page 25, will tell you what the function turns into. That's where your shortcuts for finding derivatives are. And then bracket, you multiply by the derivative of the bracket. And you can see I could actually multiply that 27 there by the 25 over 9 if I wanted to. Okay, and I'm going to get, and there's a minus sign there. That'll simplify to minus 75 pi. So all I'm doing there is I'm multiplying that 27 by that minus sign and by that number there. I get minus 75 pi times sine 25 pi over 9t. That's my derivative. Right? Now, remember, if I put that equal to 0 and solve, I could have found my maximum minimum values from the earlier part of the question. Yeah? So I could have done that if I wanted to, or if I find the derivative like this. So there's my derivative there. Obviously, what I just got to do this time is just sub in that number there. Okay? Just want to sub in the number there. And because the number here, this should actually read to 2 decimal places, because it's actually a decimal, so it wouldn't be to the nearest whole number. So if I just sub in the value of the 0.012 seconds, so the p prime of 0.012, just throw the number in. It's minus 75 pi times sine 25 pi over 9 multiplied by the 0.012. And that comes out like minus 0.43 there, but it's a negative number. Now, just in terms of the units, remember it's a rate. So what's the pressure measured in? Well, the pressure's in millimeters of mercury, right? And what's the time in? Seconds. So it's millimeters of mercury per second. And notice it's negative. Okay, that means the pressure's going down. Right? That probably, again, if you look at your graph, doesn't that make sense when I look at the graph? See it? So 0.012, where's 0.012 seconds? Well, see, there's the halfway point there, isn't it? That's the halfway point there. Okay? Which is 0.36. So for the first 0.36 seconds, the blood pressure is going down. For the next 0.2 seconds, it's going up again. So any number between 0 and 0.36 should give me a negative rate. And between 0.36 and 0.72 should give me a positive one. So that fits in my head. 0.012, the rate is negative. So that looks right. And I put my units in. So just keep your eye on that. If he does ask a trig graph long question, he can for sure ask rates, even though it's a calculus question. All right? And you do it the same way you would any other. And then part 6. Okay, it says find the average value. So again, average value, that's integration. Okay, so differentiation for rate and average value is integration, right? So you want to find the integral here and divide. So what I've got to do now is I've got to integrate the function, 27 times cosine 25 pi over 9t plus 108 with respect to t, and it says over the first 0.5 seconds, that's from time 0 to time 0.5. Okay, so that's the integration I want to do. Now, when you're finding average values, I know a lot of you guys are taught the 1 over b minus a. That's perfectly fine. I do the division at the end, but if you put the 1 over 0.5 minus 0 in front, that's the same thing. Okay, that's entirely up to you. Okay, so when you're doing average value, you will be dividing. So it doesn't matter whether you do the integration then divide at the end or put the 1 over 0.5 minus 0 in front. It's the same thing. Okay, they're both okay. So again, when I'm integrating, it's number function bracket. It's the reason I use this shortcut when I'm doing differentiation or integration. It's number function bracket. So again, it's the number here, the 27, the function cosine, and the bracket. So when you're integrating, again, the number stays put. So 27 stays where it is. Okay. Then function. Because I'm integrating now, I go to page 26 to see what the function turns into. So when you're differentiating, it's page 25, because that's where your shortcuts for finding derivatives are. When you're integrating, it's page 26, because that's where the shortcuts telling you what integrals are found, right? And page 26 will tell me that when I integrate, cosine becomes just sine. So that becomes sine. Okay? There. Right? So it becomes sine 25 pi over 9t. And then finally, bracket. When I'm integrating, I divide by the derivative of the bracket. When I'm differentiating, I multiply. When I'm integrating, I divide. So if I differentiate 25 pi over 9t, I just get 25 pi over 9. Like that. Now, I'm not going to bother trying to simplify that at all. Okay, my calculator will sort that out for me now in a second. And again, don't be that guy. What happens to the 108? Remember, it doesn't disappear. When you're integrating, when you integrate a number, you put the letter back in. So if I differentiate 2x, I get 2. If I integrate 2, I get 2x. So when you integrate the number 108, you get 108t. A lot of people forget that they'll just disappear it altogether. All right? There's your integral. And now all you just got to do is shove in your two values. So if you're doing that differentiation or integration, just think of that little shortcut, number function bracket. Okay, in both cases, the number in front, if there is one, stays put. Function, if you're differentiating, go to page 25. Integrating, page 26 to see what the function turns into. And if you're differentiating, multiply by the derivative of the bracket because you're using the chain rule. If you're integrating, do the opposite, divide by the derivative of the bracket. Right? So you just have to shove some values in then. If I put the 0.5 in, so put the bigger number, the 0.5 in for t first of all, okay, and that gives me, it's like 54.23 or something. That's what I get if I put the bigger number, the 0.5 in here and here. Put the 0 in, you get 0. Subtract one from the other, you get 54.23, right? So that's my integral. And then to get the average value, you want to divide that by the difference between these two numbers. So if I divide that answer by 0.5 minus 0, that's the equivalent of, any of you who did it that way, put the 1 over b minus a in front, that's the same thing. Right? So you either put the fraction in front of that at the very beginning or you do the division at the end. That's entirely up to you. But you've got to do the division there. When I do that division, it comes out at like, it's 108.47. So that's about 108 millimeters of mercury is the average value. Now that covers pretty much everything that he would normally ask on a trig function question. Okay, sketching it out, find the maximum minimum, putting a number to the function, multiplying it out, or solving an equation, or if he might ask you for a rate or an average value, that's possible even though it's a paper 2 question. Okay, so that's the first thing then. So secondly then, in terms of trigonometry, question 2 here. Now, a question this time dealing with a diagram. Whether it's a flat diagram like this, or whether it's an area and volume diagram, or whether it's a three-dimensional problem, the approach is always the same. All you're going to be doing here is solving triangles, using your sine or cosine rule, maybe using Pythagoras or using the sine, cosine, tan ratios. You might be using parts of a circle, okay? But the approach you take is the same, right? The same way in the first question there I said, look, you read the question carefully first. And what I meant by read the question there was I sketched the graph. I'm going to do the very same thing here. I'm going to read this question here. So look what this one says. It says, competitors in an ultramarathon event are required to complete the course shown in the diagram below. They start from P, okay, so they start from the point P, and they run 5 kilometers to Q. Okay, so that's 5 there. Right? So they run from P to Q. That's 5 kilometers there. Right? They then run from Q to OR. We haven't a Scooby how long that is. Okay, and then another 10 kilometers from OR to S. Okay, so that's 10 kilometers there from OR to S. Okay, so we've got that 10 there, right? It says they then run from S to T and then from T back to P to complete the course. So I fill those measurements in, that's fine. We're told the angle QPR is 120. Okay, that's QPR, that's 120. Now notice, 120 degrees. So I put my calculator back into degree mode. If I'd left you to your own devices there, I'm fairly sure 1/3 of you would have been wading through this question, getting all the wrong answers, saying, what am I doing wrong? Do I really suck at maths? No, you just forgot to put your calculator back into degree mode. So you've got to check that when you're dealing with trigonometry. Are you working in radians or degrees, and switch it immediately. So we're in degree mode here. The angle PTS is 65.16, so it's PTS, this one here. So that angle there is 65.16 degrees. And the angle, or sorry, the side POR is 16. Okay, so this side here is 16. And PS is 14. Okay, so this side here is 14. And we're told that PT and ST are the same length. You can see PT and ST are both marked with dashes here. So I've now filled in all the information given the text on the diagram. That's good practice, because it'll make it so much easier now when you come to solving triangles. I'm not going to be rooting around looking for information. Okay, I can get stuck in. Now, just notice something here. I can actually do a little bit better. It doesn't matter if you don't spot this, but it'll just make life a little bit easier down the road. You'll spot this at some stage. Do you notice here that because this side here and this side here are the same length, it means the triangle PTS is isosceles, isn't it? Right? And I know this angle here is 65.16. So this one here and this one here, those two base angles are the same. The triangle is isosceles. Do you see that? And I can find out what it is if I subtract 65.16 from 180 and divide by 2. I know what those angles are. Now, if I spot that now, I'll write it in. Otherwise, I'll maybe see it a little bit further down the line. But if I do that, I get that those two angles there, that one, they're both 57.42. So that angle there is 57.42 degrees, and so is that one. Now, it doesn't matter if you don't spot that now, but I would suggest if you get a diagram-based question like that tomorrow, that's worth your while. Spend a few minutes, 3, 4, 5 minutes before you get stuck into the question doing that. Read the question carefully. Put everything in on the diagram. Is there anything else I can work out? Because if you did nothing else, that 57.42 on your diagram gets partial credits. You notice in the marking scheme, for example, when you're doing geometry questions, it'll tell you that, look, if you mark two angles as being the same, either in text or on the diagram, you'll get your partial credits. So if I can identify, look, I know those two angles are the same and I know what they are, there's your partial credits straight away. I'm beginning to build up marks here, same as we did previously. All right? So now I've got the diagram fully filled in. Now I'll start doing some calculations. So we're first of all, in part 1, we're asked to find QOR. So notice that means I'm asked to find this side here, QOR. Now just look at the triangle it's part of. See the triangle PQS? I can see just from my diagram, I know the angle 120. I know this side's 5, that side is 16. It's going to be much quicker now to spot the cosine rule, yeah? You can see that I'm trying to find the side QOR here. I can see at a glance what I know about that triangle. That's a cosine rule calculation. And your cosine rule is on page 16 of your formula booklet. So when you're setting up the cosine rule, okay, if you remember the cosine rule, it looks like that in your formula booklet. It's written this way. Remember, it's a squared equals b squared plus c squared minus 2bc cosine a. All you got to get right is that the side by itself over here is the one that's opposite the angle. And in my diagram here, that's QOR. Okay, so QOR squared is equal to the other two sides, just b and c. So it's going to be what? 5 squared plus 16 squared minus 2 times 5 times 16 times cosine. The angle is 120. And now the right-hand side there is all numbers. Just dump the whole thing into your calculator. Okay, don't work out the numbers individually. Just dump the whole right-hand side into your calculator. So QOR squared there comes out as 361. So QOR is the square root of 361. Which is exactly 19. And again, put your units in. Units, units, units. Okay, he'll take a mark away from you anytime you leave out units. Fairly simple 10 marks probably to get my score moving once I kind of hold the information filled in. And now what I tend to do now is go back up here. And now that I've got new information, put that in the diagram. So I now know that this side here is 19. Yeah? Okay. So that's part 1. Part 2, find the angle PRS. Where is PRS? Well, again, look at your diagram, PRS. There it is there. And see, just at a glance now, look at the triangle. I know all three sides. I know the 16 here, I know the 10 here, and I know the 14. Okay, so I know all three sides. I can see that at a glance now. So again, that's a cosine rule question, isn't it? When you know all three sides, try and find an angle. That's another job for the cosine rule. But see, when I put the information in on the diagram as I did at the start here, I'm not now rooting around trying to find the information I need to solve the triangle. I can see at a glance what I know. So I'm not kind of trying to work out what the best way to do this is. I can just see by looking at it, right? So again, if I use my cosine rule there, The side opposite the angle I'm trying to find is the 14, right? So that's the 14. So I'll just write that in as 14 squared. Okay, so 14 squared is equal to the other two sides are just 16 and 10. All right, so it's 10 squared plus 16 squared. Minus 2 times 10 times 16 times cosine of the angle, P or S. Right? So I just fill in the cosine rule. Now what I tend to do with the cosine rule, don't bother working out all the numbers individually, right? Just move these two numbers over onto the left-hand side and then divide by this one, right? So I just get 14 squared minus 10 squared minus 16 squared. So just move these two across, they become negative. And then divide by that number there, making sure you bring the minus sign with you. Okay, so divided by minus 2 times 10 times 16. Right? That's equal to the angle, the cosine of the angle P or S. And if you put that catastrophe on the left-hand side there into your calculator, it comes out a lovely fraction, a half. You know, when you get a nice sexy fraction like that, you're fairly sure you've done this correctly. Okay, when I start getting lovely round numbers like that, I'm probably doing it correctly. So then the angle P or S is the inverse cosine of a half, which is 60 degrees. So again, see that, like the previous question, a couple of easy bits, just solving triangles just to get you warmed up, get you settled into the question, right? So I now know that that angle there is 60. All right? Gradually building up more and more information about this diagram. Now, part 3 then, find the total length of the course. So find the total length of the course now. So again, if I have a look at my diagram, you can see I'm trying to find the length of all of the sides. Remember, the key thing to notice here is the two dotted lines there, PR and PS. You're not running along those. They're not part of the length of the course. If you run along PR or PS, you're either lost or cheating. Okay, they're not part of the course at all right? So you're going from P to Q, Q to R to S, S to T, and T to P. He told you that in the question. So you notice I know 3 of the sides already. I know the 5, the 19, the 10. All I've got to do, it looks to me now, is find ST and PT. And delightfully, they're the same length. We're told they're about the same length. So all I've got to do is find PT, and then I'm in business. And do you see now, because I've already done this thought process, just by looking at that triangle, I can see it's a sine rule question. Because you can see this question here, in this thing, I know what this angle here is. I know the angle 65.1, and I know the side opposite is 14. Right? I know that this angle here is 57.42, and the side opposite that is ST. So because I'd have already done the thought process there of working out those two angles, 57.42, it speeds me up. If I hadn't spotted at the start, I'd have to puzzle that out now. Yes? So it doesn't matter if you didn't see that when I was doing the diagram originally, you'll spot it now. You have a good look at that triangle there and say, oh, wait a minute, two sides the same length, it's isosceles. That's what he's really testing here. So this is a sine rule question because I know I have a pairing in there. All right? So if I just set that up, remember, write the pairs as fractions. So PT over sine 57.42 degrees is equal to 14 over sine 65.16 degrees. And then just multiply across by this guy here to give the PT by itself. So PT then is 14 times sine 57.42 degrees over sine 65.16 degrees. And pop that into your calculator, it's like 12.9996. Let's call that 13. That's 13 kilometers. And just make sure you don't rush here. A lot of you will kind of say, look, I got that and I jog on. That's not the answer to the question. You were asked the length of the course. You've got to remember, add the 5 sides together. That's just kind of the last calculation. So the total length of the course then is just add all the sides together. So it's 5 plus 19 plus 10. They're the ones I knew already. And then we've got two 13s then, because we're told out they're both the same length. And that comes out at a nice round 60k. 60 kilometers. Right? So again, that one there, not incredibly difficult, but actually, when you get these diagram-based questions, they're very often no more difficult than that. The hard part is sorting out the diagram. And you make life difficult for yourself if you kind of say, look, I'll just skim the text, go down and read question 1, and then go back up and start trying to pull out the information I need to solve it. And then read part 2 and then go back up. The whole thing is very inefficient. and makes it feel like it's hard going. If you spend a few minutes at the beginning just putting all the information in the diagram before you get started, it makes it much more efficient. You're much more likely to spot what's going on. If the diagram gets very busy, you can even sketch the triangles separately and put the measurements in beside them. Remember, if you do that, if you put in any angles or sides that weren't given the text, you're going to be getting partial credits. You're showing the examiner you've made progress here, right? Part 4 then. It says a drone is used for security purposes to monitor the area inside the course. The region monitored by the drone is in the shape of a circle, C, with center O, where O is the midpoint of PS, such that PT and ST are tangents to the circle. Find the radius of the circle, okay? So if I go back up to my diagram then. Okay, so you can see that we're told that these two sides here are tangents. So that's a tangent there, and that's a tangent there. That's where we get this right angle from. Remember that a tangent and a radius form a right angle where they meet. That's one of your theorems. Okay, don't want to have to prove, but anywhere a tangent hits a circle, you get a right angle. So if he hadn't given me that right angle, I'd be putting one in there myself, but I've got one as it turns out, and I'm asked to find the radius. So notice here, he told me that O is the midpoint of PS. So because PS is 14, it means that bit there is 7. So look at that little right angle triangle. See the triangle, if I just call this point here U, do you see the triangle PUO? There's the right angle there, all right? There's P up there. There's U there. There's the right angle. There's O here. I know that's 7, yeah? And this angle here is the 57.42 degrees. And that's the radius. See, it goes from O to the edge of the circle. That's the radius there. There's the triangle I'm going to solve. Now again, when you see it, it's very quick and easy to solve. It doesn't have to come to you that quickly. Remember, you've got thinking time. I did talk to you about this on Thursday, but that your approach during the paper should be the same. That when you get your paper tomorrow morning, you read all 10 questions, every part of all 10 questions, choose the 8 you're going to do, the 5 short and the 3 long you think suit you best, and do them in the order in which you're confident in your ability to do so. Because if you start off by doing the questions you're sure how to do, they won't take you long. You'll get your score moving without taking up too much of your clock. That gives you thinking time when you're doing questions you're less sure how to do. So here, I don't have to jump on that straight away. I've got a few minutes. If it takes me a few minutes to spot that, that's fine, because the calculation takes no time at all, right? So you can see I can just use the sine ratio there, yeah, because the OR is the opposite. 7 is the hypotenuse, because it's a right angle triangle, and I've got the angle 57.42. So now the calculation, once I've spotted that, is very straightforward. So in this case, it's a little bit like some of the long questions on paper 1. That because of the way the questions, all the information that's coming at you there, spotting what needs to be done takes some time. But what needs to be done is actually very quick and easy. Okay, so you give yourself a break and a chance to do that, all right? So if I just use the sine ratio then, so the sine of 57.42 degrees is equal to the opposite, which is OR, over the hypotenuse, which is 7. So multiply both sides by 7. 7 times the sine of 57.42 degrees is equal to OR. And that comes out, it's about 5.9. It says 2 decimal places, so I might just put it as 5.90, although if it rounds like that, he won't penalise if you give it as 5.9. If your next decimal is a 0, I think it's like 5.898. So that'll be 5.90. If he said 2 decimal places there, he'll give you full marks for just giving it as 5.9, okay? Just depending on how you rounded the 57.42. Okay, you might have got an answer that's a different decimal. So that's the radius, 5.9. And then the last part of the question then is quite straightforward. Find the percentage of the total area enclosed by the course that's monitored by the drone. So how much of the area inside the course is monitored by the drone? So again, if you just go back and look at your diagram, and again, even write this down. As I said, showing the examiner, I know what you want me to do, but I don't have a Scooby how to do it, is my low partial. So do you see, to get the area inside the course, I've got 3 triangles. Yeah, I've got this triangle here, PQR. I've got this triangle here, PRS. And I've got this triangle here, PST. So the area of those 3 triangles added together will give me the area inside the course. The circle, obviously, I now have its radius. I can just use pi r squared and subtract one from the other. That's the idea. So there's a few little calculations to do here, and every one of those I navigate successfully will get me marks. Okay? So remember, your formula for getting the area of a triangle, they're all on page 9. There's 3 different areas of a triangle formula on page 9. The one that I'm probably going to use here is a half AB sine C. You know, the one where you need 2 sides and the angle in between them. Because in each triangle here, I do know 2 sides and an angle in between them. So I'm going to use that for each calculation. Okay? So I'm going to use a half AB sine C in each case here. Sorry. Okay? So, if I just do the first one, so the triangle PQR will just be a half, just two sides, so it's 16 by 5, because they're the two sides on either side of the 120, times sine 120. Pop that into your calculator, it's about 13 square kilometers, that's that triangle. If I do PRS with the same formula, okay, if I'm going to use the 60-degree angle, the sides on either side of that are the 16 and the 10. So it's a half of 16 times 10 times the sine of the 60 degrees. And that's about 69.3. And then the last one, PST. Okay, again, it's a half. Let's say we go to two 13s. So 13 by 13 by sine 65.16. So all you need to remember is two sides and the angle that sits in between them to use that formula. That's about 76.7. And if I add all those together, I get 159. Now, they're all in kilometers squared, but I don't need to include the units there because they're not final answers. As long as your final answer has the appropriate units, you won't be penalized, but they're all in kilometers squared. That's the total area inside the course. The area mounted by the drone, well, remember, that's the area of a circle. Okay, so the circle is just pi r squared, which is pi times 5.9 squared. 5.9 was down to the previous part of the question, which comes out at about 109.4. And I just want to express that as a percentage of the full area. So the calculation is not too bad. It's 109.4 over 159 and multiplied by 100. And to the nearest whole number, that's 69%, of course it is. All right? So the nearest whole number, that's your answer there. Right? So you can see that's another one there's just a few little steps there, and every one of those calculations you do correctly is going to grab you more marks. Okay, so if you do get a diagram-based question, which is very likely, okay, at some stage here, just spend the few minutes at the beginning putting the information in the diagram. Make sure you're clear on what you know on the diagram before you start doing the calculations. It'll just speed your calculations up, okay? And watch out for hints. The right angle he gave me there when I was trying to find the radius, he'll put information that you need in the diagram, sides marked as being the same length. Just keep your eye on that, right? Now, the last trigonometry question here, just before we kind of move on to the stats and probability then, all right, is a trig equation. Again, part of a short question here. It's always a likely short question. Remember, the other stuff then in trigonometry is the proofs and equations, working with the formulas. Now, if you remember that in terms of proofs, there are 8 trigonometry proofs on the Leaving Cert paper. If you haven't learned any proofs at this stage, I'm not sure if there's a huge amount of value in sitting down trying to learn them now. Okay, at this stage, all right? But remember that there are 8 of the trigonometry proofs. The first one, remember, is your cosine squared a plus sine squared a equals 1. Okay, the Pythagorean identity. You've got the proof of the sine rule. Okay, you've got the proof of the cosine rule. And you've got the fairly gruesome one, the cosine a minus b. That takes about 4 pages and all of your will to live. Okay, that proof there, a huge one, right? Now, those 4 there are never likely. Okay, so when you're getting ready for proofs, I would always say they're at the bottom of my list. Okay, maybe if I'm looking for a H1 and I'm really concerned, I might try and know those just to be safe. But they're never likely proofs because they're too long. And my suspicion is if he did ask one of those, it'll end up being worth 5 marks. If you remember back in 2017, the first time he tested the amortization formula, it was worth 5 marks because that's a really long proof, all right? So I'm not sure there's a lot of value in learning those off in a lot of detail for what may end up being worth 5 marks. The next 4, though, are quite short and are examined all the time, right? So you've got the cosine A plus B formula, okay? You've got the cosine 2A formula, the sine A plus B formula, and the tan A plus B formula. Now, those bottom 4 there, they're all only like 3 or 4 lines because all you're doing is you're subbing something into one of the ones of higher than on the list, okay? And if you're using something higher than this, you don't need to prove that first. So all you're doing is you're taking a formula higher than this and subbing something into it. So they're only 3 or 4 lines, and they're tested all the time, right? So if you haven't done any proofs at all and you're kind of worried, well, he didn't ask any proofs on the paper yesterday because the De Moivre's theorem one wasn't really a proof. It was a De Moivre's theorem question, all right? So he didn't ask any proofs. He might put one in the paper there. Those 4 might be worth casting your eye over, excuse me, because they're only like 3 or 4 lines. And they get examined all the time because they're quick and easy, right? So they're the 4 short trig proofs there. If you're asked to prove something else, you can use any of those 8 as your starting point. Okay, so if you can take any of those 8 there and shove something into them, that's where any other proof will come from. Okay, that's the kind of approach here. So if you're solving this equation here, obviously what you want to do first is get the cosine by itself. So if I start off by saying, look, I get root 2 cosine 3x equals -1, move the 1 over onto the right-hand side, then divide by that root 2, you get cosine 3x is equal to -1 over root 2. So there's your standard trig equation now. And again, there are as many different ways of doing those as there are people doing them, okay? You've all been taught a different way of doing that. I'm sure a lot of you use the cast circle or whatever what you want to call that. It's entirely up to you. Okay, but the key thing here is to, first of all, get your reference angle. That's going to be your partial credit. In this one here, you'll probably get the low partial for doing that, for rearranging and getting the cosine by itself on one side here. Then remember, to get your reference angle, you can ignore the minus sign here, because that minus sign just tells you which quadrants your answers are in. It has no bearing on the size of the angle itself. So if the number on the right-hand side is negative, you can ignore that for the purpose of getting the reference angle. So your reference angle then is the inverse cosine. So the inverse cosine of 1 over root 2 is 45 degrees, because remember we're in degrees here. All right, that's my reference angle. And then all I've got to do is work out which quadrants my answer is. So that's what you use the cast circle for, many of you. Otherwise, remember, you've got that shortcut there. So if you're dealing with sine, the top 2 quadrants are positive, the bottom 2 are negative. If we're dealing with cosine, the right-hand ones are positive, the left-hand ones are negative. Or if you're dealing with tan, they alternate. Now, that's the same as the cast circle. It doesn't matter how you do that. It's entirely up to you. I'm sure you've all got your own method here. But the key thing here is we're dealing with a cosine value here, which is negative. So you can see that's quadrant number 2 and quadrant number 3. So the 2 angles I'm looking for in quadrants 2 and 3 here, that's where cosine value is negative. So whatever way you'd normally puzzle that out yourself. So how do you get an angle in quadrant number 2? It's 180 minus the angle. So 180 minus 45 is 135. Okay, and then in quadrant 3, how do you get it? It's 180 plus the angle. So 180 plus 45 is 225. Right? Now, if you get that far, that's your high partial. I haven't dealt with the 3 yet, but I get the high partial for getting that far. So if you can just, when you're doing a trig equation, if you struggle with these, particularly when there are numbers in front of the x, just get that far. Okay, just get the inverse cosine, inverse tan, inverse sine to get your reference angle. Work out which 2 quadrants your answer are in, either by using the cast circle or however you choose to do that, and then find what the size of an angle is in each of those 2 quadrants. That's your high partial. Now I've got to deal with the 3, remember, because they're both values for 3x. I haven't dealt with the 3 yet. So 3x then is equal to 135 and 225. So divide across by 3, x is 45 degrees or 75 degrees. Right? So I divide by 3. But remember, the 3 in front has another effect. It changed the number of answers as well. Remember what we did back in question 1? Right? If you're drawing the graph of a trig function, the number by itself is your center line. The number in front of the word sine or cosine, remember, is the amplitude. It's how far above and below the center line your graph goes. And the number in front of the letter here tells you what the period is. So like we did in question 1, a full circle divided by that number there will tell you what the period of a graph is. Right? So a full circle, remember this time we're dealing in degrees, so a full circle is 360 degrees. Divided by the number in front of the x, which is 3, that means the period of this graph is 120. So a full circle divided by the number that's in front of the letter, okay, tells you what the period is. So these answers repeat themselves every 120 degrees. So all I've got to do now is take the 2 answers I've got and keep adding 120 until I go outside that range there and I've got all my solutions. Now, there are other ways of doing that. As I said, everybody's been taught their own way of doing it. That's just the way I've always thought it is, because I like the link in my own head between the number in front of the x and the period of the graph. It's the same way I think of when I'm dealing with trig graphs. So if I just keep adding 120s then, right? So if I take my 45 degrees, add 120, I get 165. Add 120, I get 285. If I was to add 120, I get 405, so I'm gone bust there, so I don't need any more there. Do the same with the 75. Add 120, I get 195. Add 120, I get 315. And if I add any more, I'm bust. So there are my 6 solutions there. They don't have to be given in order. Okay. So that's the trig equation. So that's probably the bulk of trig there. Trig graph, potential long question, because there was none on paper 1 yesterday, diagram-based trig, and then maybe proofs and equations, the other kind of stuff to have a look at. It's the bones of your trigonometry. Okay. Now, The second topic, we'll take a break in a moment or two, just to give you a chance to get some water, go to the bathroom if you need to. Okay, what I'm going to do next, I'm going to do the two stats questions, two quick stats questions next. There's the one in particular I want to highlight for you here in French statistics. Okay, we'll take a little breather then maybe, and then before we come back and do the probability. So I'm just going to start off with one of the statistics questions first. Okay, I'm going to just do that because it's quite quick. I'll do the Z values one. Question 8, page 22. Now, again, as close to a banker as we've got, you should be getting a question on Z values in there somewhere, all right? And again, what are the clues? What's the buzzword you're looking for here? See what it says there? So it says there in question 8, the actual amount of flour in 1 kilogram bags produced by a company is approximately, there you go, sports fans, normally distributed. In my head, that's Z values. It could be the empirical rule, but it's almost certainly Z values, because anything you do with the empirical rule, you can do better, more accurately with Z values. Remember, he only ever mentioned the empirical rule once on the Leaving Cert paper, and he said using the empirical rule or otherwise, which means using Z values instead. So if I see the words normally distributed, I'm assuming it's a Z values question. Okay? With a mean of 102 and a standard deviation of 18. What percentage of bags produced by the company contain less than 1,000 grams of flour, correct to 1 decimal place? Right? So you just think about this for a second, again, just me kind of puzzling it in my own head. That's what normally distributed means. It means that the graph is symmetrical like that. And the mean given here is 1012 with a mean of 1012. So that's what the weight of these bags looks like. It's a symmetrical graph, normally distributed, with a mean of 1012. All right? We're trying to find what percentage of bags produced by the company contain less than 1,000 grams. So 1,000, you can see, is down here. It's below 1012. Right? And less than 1,000 grams is that. That's what I'm trying to find. Now, any of you who've done this with me before, who've done this topic with me before, know the reason I sketch it out like that. Because my sketch tells me now the answer should be less than half. See, less than half the graph is sketched. So what that means is that I'm not memorizing any rules about when I got to subtract from 1 or not. Sometimes when you find a value from the tables, you got to take it away from 1. And it's kind of tricky sometimes to work out when that's the case. All right? The sketch means I don't have to. So my answer here needs to be less than half. So I'll get my Z value. Remember, your Z value formula, it's on page 34 of your formula booklet, right in the very middle. But that's when you probably should know it. Just take away the mean, divide by the standard deviation. Okay, so Z here, it's x minus mu over sigma. Mu is the mean and sigma is the standard deviation. Okay, so it's going to be x, which is 1,000. Take away the mean, 1012. Divided by standard deviation, 18. And that comes out at minus 0.67. Remember, you always take it to 2 decimal places, and it's 6 recurring on your display screen. It's not 6. So that's 0.6666666. So because you round that off to 0.67, okay, to 2 decimal places. And that's the number you're going to look up in your table. So remember, you don't need to look up the negative Z value because they don't exist in the tables. Just look up that number there. Okay, 0.67 in your tables. Find the 0.6 down the left-hand side and the 0.7 across the top. And the number I get there is, when I look that up in my tables, I get 0.7486. Right? Now, do I subtract from 1 or not? Well, look at the sketch. Yes, I do. That 0.7486 is more than half. Yeah, it's bigger than 0.5. And my shaded area is less than half. What that means is the 0.7486 is what's above that line, not below it. So I subtract from 1. So you subtract from 1 if the number you get from your tables doesn't match your sketch. In this case, my sketch, less than half the graph is shaded. The number I got from my table is more than half, so I'll subtract from 1. So it's 1 minus 0.7486, which is 0.2514. And then as a percentage, we multiply that by 100. It's 25.1%, 1 decimal place, so 25.1%. Now that's how you do Z values. So again, the simple sketch, there's your partial credits. As I keep stressing, you're showing the examiner, I know what you want me to do. All right, you get the Z value, you get the high partial. Look it up and interpret your answer, you get all 10 marks. Right? Now, one little thing to check in part 2 here. A random sample of 139 bags produced by the company was taken. Find probably that the mean weight of this sample is less than 1015. So we're not taking a single bag of flour here and seeing how its weight compares to all the bags produced by the company. We're taking a sample group of 139 and seeing how their mean weight compares. It doesn't change how you do the question in the slightest. I'll sketch it the very same way. There's my normal distribution there. Sorry. Okay, so there's my normal distribution there. There's the 1012 in the middle. This time the number is 1015. That's up there. It's above the mean. okay? And it's less than 1015, so it's this shaded area here I'm looking for. So you can see this time my answer should be more than half. So if the value I get from my table is more than half, I don't subtract from 1. If it's not, I will. That's what your sketch does. It means I'm not memorizing rules of when I subtract from 1 or not, right? Now, the only difference this time, remember, is because we're not dealing with a single bag of flour, it's a sample group. So remember, that just changes the formula I use to find my Z value. My formula is this one here. Remember, it's Z is equal to X bar minus mu divided by sigma over root n. Remember, that's the one that's on the top of page 35. So the previous question is the one where you're dealing with single bags. Here's the one where you're dealing with a sample group. That's the only difference. Okay, how I draw my sketch and what I do with the Z value when I found it doesn't change. Because the only difference here is I've got this n in here now, which is the size of your sample group. So if you're comparing one individual to the population, you just use your normal Z values formula. If you're comparing a sample group and their mean result of the population, you just tweak your Z value formula by using the one that's on the top of page 35 instead. The one that's the n in there, right? So I fill my values in. It's 1015 minus 1012 all over 18 divided by the square root of 139. And that gives you a 1.96. So there's a familiar number. You'd almost think I planned that. All right? That number 1.96, we'll kind of see that one now, okay? So when you go to your log tables, you look that one up in the tables and you get 0.975. Right? And that actually answers your question here because it says what's the probability the mean is below. That works, doesn't it? Because that number is bigger than half. It's bigger than 0.5, so is the shaded area there. So you can see what that means, just to remind you that if you on the normal distribution on page 36, 37, okay, the number 1.96 there, 0.975, so 97.5% of the data lies below that, which means 2.5% of the data lies above. Right? So if you subtract that from 1, you've got 2.5% of the data above that number. And if you've got the minus 1.96 down here, then obviously that's 2.5% there as well. So you can see that means 95% sits in here. That's why we use that number 1.96 in your 95% confidence interval. It's the number that 95% of the data lies between, plus or minus 1.96. That's what you're kind of seeing with that number there. Okay, so we do the 95% CI now after the break. We'll have a look at that. Okay, so you can see there's two Z value calculated. The only difference there being the n. Now, if you left the n out and just ignored the 139, you get the high partial. Of course you will. Because you've shown the examiner I know how to work with Z values, I know how to sketch it out. I'm not going to get 0, but I won't get full marks if I don't factor in the 139. And then the tricky question, the working backwards one here. Make sure you've had a look at this one. It says the 10% of bags that are heaviest and the 10% of bags that are lightest are not sent out to retailers. Find the range of weights which would be sent out to retailers, giving your answer to correct the nearest gram. So this one here, where you're given a percentage, you're trying to work backwards to find the corresponding weight. He always asks this. Okay, so keep your eye open for that where you're working backwards. Anticipate it, right? So let me just find the heaviest ones first, because actually the lightest ones will be the same thing, right? Sketch it out. There's your normal curve there. There's the 1,000 in the middle, like that. Sorry, the 1012 in the middle, right? And there's a weight up here, X, haven't a clue what it is. But I know that 10% of the bags weigh more than that. Okay, so whatever that cutoff point for the top 10% is, that's the weight I'm not going to send bags out if they're heavier than. Okay, so I want to find, that's the idea here. And that sketch, there's the partial credit. I'm showing the examiner, I know what you want me to do. Okay, try and make sure you nail that down, right? So the important thing when you're doing the work backwards here is if there's 10% above that line, it means there's 90% below. So turn that into a decimal and you get 0.9000. So now don't look that number up along the sides of your table. Find that number inside the table. Remember, the numbers across the top and bottom are Z values. The numbers inside are your percentages. Right? So when I was going forwards, I had my Z value and I look up a number that gives me a percentage. That number there is a percentage. Just turn to decimal find. So find that number inside the tables. I can't find 0.9000 exactly. The best I can do, there's 0.8997. That's the closest number I can find inside the tables on page 34, 35. Or sorry, page 35, 36. Right? So if you go sideways from that number and go up, you'll find the matching Z value. And the Z value is 1.28. Okay, that's just finding that number inside the tables, go sideways and go up, right? So the Z value is 1.28. Now all you got to do is work backwards, right? So remember, so we know that this X value here, how would you find the Z value? So the Z value, it's X, take away 1012, and divide by 18. So if I take that weight, whatever it is, subtract the mean, divide by the standard deviation, I should get the z value 1.28. And now, Robert's your mother's brother. You can finish it off from there. All right, so you just multiply both sides by 18 first. All right, remove the fraction. So multiply both sides here by 18. Bosh, they're gone. And the x minus 1012 is equal to, that's like 23.04. Let's just call that 23 because it's set to the nearest gram. And I move the 102 across, I get x is 1035. So that's the cutoff point for the top 10%. And it might be obvious, it might not be, but see the way the difference between 1012 and 1035, that's how far above the mean you had to go to find the top 10%. So because the curve is meant to go down the same distance to find the cutoff for the bottom, so 1012 take away 23 will give me the other end, and that's 989. Okay, so that's your range from 989 grams to 1035 grams. Bags in that range there are the ones that are the range which would be sent out. Anything outside that range is too heavy or too light. Now we've got to be anticipating that as a potential question. And that's going to springboard us nicely into having a look at the hypothesis testing and p-values, which I'll have a look at now in a second. Okay, so we take a little breather there. We're kind of going for an hour there. Maybe take 5 minutes or so. If you want to go to the bathroom or fill your water bottles, we do that, and we'll pick it up again then in about 5 or 10 minutes. Because, yeah, so now you see, if you did that, you're going to get the high partial because you're showing the method correctly. That's fine. I've done my Leaving Cert, so if I make mistakes like that, that's fine. And this month's check has already cashed. So in this case here, I think the calculator was probably in degree mode, not radian mode, for part 5. I think the right answer was minus 25. I think somebody told me, and I'm willing to trust that. All right. So that's just in the part 5 on page 6. Right? So what we're doing then, just before the break, was we're kind of starting into the statistics, and I had a look at the Z value question, right? So I want to do the one before it then, which has the inferential stats in there and a scatter plot. Now, a scatter plot is possible. Okay, again, there's never kind of a year where I say a scatter plot's a banker question. Any year where he hasn't asked scatter plot the previous year, it's potentially could. Okay, what he certainly has done, you know, is the last couple of paper 2s, he certainly has asked you to find OR, the correlation coefficient. So just make sure you know the sequence of button pushes on your calculator for finding the correlation coefficient OR. Okay, that's important, right? So the question 7 then is on page 19, all right? And you can see the first part here deals with a scatter plot, bivariate data, and then we go into the inferential statistics, right? So part 1 there, it says the number of hours worked on a particular day and the total number of bricks laid by a team of 10 bricklayers was recorded. The results are shown in the table below. So you've got 10 separate people here, the number of hours they worked, and the number of bricks they laid, okay, are given the table there. You're asked to find OR. Now, what I would make sure I know how to do, once I get a table of bivariate data like that, okay, where everybody was asked 2 questions, right? The question we're asked here is how many hours did you work and how many bricks did you lay, all right? So everybody was asked 2 questions there, all right? I'd make sure I know how to put that data into my calculator and find OR, X bar, and Y bar. Okay, you just put the data into your calculator once, you just push kind of 2 very simple buttons, and it pulls out those 2 values for you, or those values for you. Okay, so if I do that, in this case, OR ends up being 0.66, or thereabouts. X bar ends up being 5.5, and Y bar ends up being 240. Right? So I would normally kind of make sure I've got those. So just if you're not sure, just even check the instructions in your calculator how you find those 3 numbers. Just put the table of data into your calculator and find those 3 values to remind you what they mean now. And then part 1 just says find OR, corrected 2 decimal places, so that's 0.66, the correlation coefficient. Okay, make sure you can find that. He's thrown in as a short question now on a couple of occasions. Right? Then part 2, it says there's a positive correlation between the number of hours worked and the total number of bricks laid for this team. Explain the underlying term in the context of this data. So what does a positive correlation mean? Remember, a positive correlation means, if you just look at the graph, which is coming up now in a second, okay? So in terms of the graph here, okay, what positive correlation means is as whatever's on the x-axis goes up, whatever's on the y-axis goes up as well. That's positive correlation. As one goes up, the other goes up. Negative correlation means as one goes up, the other goes down. So that's what those correlations mean. Whether as one goes up, the other goes up is positive. As one goes up, the other goes down is negative. So what this means here is, as the number of hours worked increases, the number of bricks laid increases as well. Okay, that's the basic idea here. But just one thing to be careful of when you're phrasing that, all right? So if I'm trying to kind of phrase that here, what I want to say is, as the number of hours worked increases, so in other words, as x increases. And how do I know what x is? Remember, x is going to be what's across the top of your table. Okay, so when you're putting the data into your calculator, when you're dealing with it in the course of the question, okay, whatever's across the top of your table are your x values, and whatever's across the bottom of your table are your y values. And you can see that's why this is what's on the x-axis when you draw your graph, that's what's on the y-axis when you draw your graph. Okay, so if you're putting them into your table, and the top line will be your x values, the bottom line will be your y values. Okay, so in this case, as x increases, as the number of hours worked increases, okay, what that means is the number of bricks laid don't say increases. Okay, because if you say that, that sounds like it's an absolute rule. There's no variation. There aren't. There's a couple. You can see it doesn't form a perfectly straight line. The number of bricks laid tends to increase, okay, or generally increase. Sometimes it's not always the case, it's just a general trend. So as a rule, the more hours you work, the more bricks you lay. That's that's what positive means. As one goes up, the other goes down. If it was a negative correlation, you'd be saying, as the number of hours worked increase, the number of bricks laid tends to decrease. Okay, so positive means as one goes up, the other goes up. Negative means as one goes up, the other goes down. Okay, so that's the explanation there. And then finally, see what it says here. It says, find the mean number of bricks laid per hour for this team. Okay, so obviously what you could do here is you can just, is you can just take the table of data you've got and add up all of the X values to find the total number of hours worked for the entire team. All right? Add up all the Y values to find the total number of bricks laid for the entire team and divide one by the other. Or you could use those numbers there if you've got them. Okay? Just divide the average. Remember, that Y value there's the average of the Y values. It's the average number of bricks laid per person on this team. And that's the average number of hours worked. It's the average of the X value. So you can divide one by the other there as well. So if you add up the top line there, if you add all those together, you're going to get 55. If you add up those numbers there, you're going to get 2,400. Right? So you're going to divide one by this. So it's 2,400 divided by 55, or else you can divide X bar and Y bar. You get 240 divided by 5.5. All right? It's whichever way you're doing the question. Say 2,400 divided by 55. And that's like 43.63, so we round that off to 44. So on average, it's 44 bricks per hour. Right? Now, if you get a scatter plot then, it's like we do in part 4. So the data shown below is as a scatter plot there. And you can see the scatter plot includes a line of best fit. Very often he asks you to draw the line of best fit yourself. So remember, that's why I would find the point X bar, Y bar, right? So if you've got those two values, X bar and Y bar, if you plot them as a point, your line of best fit will always go through that. So if you use your calculator to find X bar, Y bar, if you just plot those numbers as a point and just draw a line heading in the right direction through that point, it's definitely going to get full marks. Okay, that's the idea here. Just remember when you're dealing with a positive one like this, it does not have to go through this point here, the origin. Don't try and force the line to go to the point where the two axes meet. It doesn't have to. Stay away from it. I wouldn't bother at all. Okay, that's the thing there. So what it says by taking readings from the graph, find the equation of the line of best fit. Now, that's just pure junior cert coordinate geometry. If you've got 2 points in a line, can you find the equation, right? So what you want to do there is you want to use the slope formula. So to get the slope of a line, it's on page 18. Okay, it's y2 minus y1 over x2 minus x1. So to do that, I need 2 points on the line. And because it's by taking readings from your graph, try and show them you did that, right? So say, for example, see if I take the number 2 here, if I go up from 2 and across, that looks pretty close to being 100 to me. So it looks to me like the point 2, 100 is on the graph. Yep. And I need a second point. So again, any others that kind of jump off the page at you? Well, yeah, the 7 looks kind of, I mean, I don't have to. I mean, it'll be right. Once it's right from my graph, it's fine. But look at the 7. That looks like it's following a grid line as well. Yep. So it looks to me like 7, 300 might be on the line as well. And now it's just junior cert coordinate geometry. Find the slope of the line there. So the slope will be y2 minus y1, which is 300 minus 100, over x2 minus x1, which is 7 minus 2, and that comes out at 40. Okay, and if you take readings anywhere else, you might not get exactly 40, but as long as it's correct from your graph, it'll be around that and you'll get full marks. It doesn't have to be exactly the same as mine. And then remember, to get the equation of a line, your equation of a line formula is also on page 18. It's y minus y1 equals m times x minus x1. So you just want to use m is the slope you found here, and x1, y1 is either of those 2 points. So let's say it's y minus 100 is equal to 40 times x minus 2. That's just using that point there as x1, y1. I'll get the same answer if I use the other one. So y minus 100 is equal to 40x minus 80. So y is equal to 40x. And if I move the 100 across here, I get plus 20. Or 40x minus y plus 20 equals 0. It doesn't matter how you arrange that. I normally give in the form y equals mx plus c. But as long as you've brought all the two numbers together, it doesn't matter what side the equal sign they're on. That's not a difficult question at all, just using coordinate geometry to find the slope. So again, for scatter plot, just make sure you can find or, and you know how to draw or find the equation of a line of best fit, a correlation line. Now, the important part of this question here, part B, again, as close to a banker as we've got, okay, on paper 2, is hypothesis testing, confidence intervals. Make sure you can do that, right? Here's now very often on paper 2 where the questions get a bit wordy. So like the long question on paper 1 on Friday, okay, that these questions can be kind of wordy. Any of you who've been doing this with me since the beginning of the year will kind of know how I go about pulling the information out of this. I'll just show you very quickly here. But once I pull the information out of this text here, I don't have to reread it. okay, because I don't have to keep rereading the text for pulling this out here. So when you're dealing with an inferential statistics question, essentially we've got the population like that, and we've got a smaller sample group, right? I just want to pull out the measurements from these. So the first thing I would do when I'm reading the text here is I want to find the number of people in my sample group. So if I just look at the text very quickly, it says a national regulatory body publishes statistics suggesting that the industry standard for bricklayers is 48 bricks per hour. In a random sample of 85 bricklayers, the mean number of bricks laid per hour was found to be 51, with a standard deviation of 19. Conduct a hypothesis test at the 5% level of significance to test the claim made by the regulatory body. So you've got a hypothesis test here. Now remember, all hypothesis tests at Leaving Cert are at the 5% level of significance. That'll never change. Okay, so you don't have to worry about that here. So what I want to do now is rip the information I need out of that text. So if you've got the little sketch that I've drawn there in the left-hand margin, the first thing you want to know is how many people in your sample group. That's the first thing you look for, how many people in your sample group. That's your value for n. And you can see there it is there, a random sample of 85, so n is 85. Right? So n is 85 bricklayers. So that's it. Now, pick your symbols. So when you're dealing with a hypothesis test question, the symbols will either be p and p hat, or they'll be mu and x bar. Depending on whether the question is dealing with proportions, or dealing with means. Right? Because there's two types of question you can ask your sample group. A question that produces a yes-no answer, and one that produces a numerical answer. So if you ask a sample group a question which produces a yes-no answer, you're going to get a list of yeses and nos coming back. So you can't put a list of yes and nos into your calculator and find a mean. All you can work out is what fraction or proportion of your sample group said yes. Okay? That's what's proportions. And you'll see the word proportion used a few times in the question there. A proportion is just a percentage in decimal form. So if you said, look, that p was equal to 0.78, that means 78% of your sample group said yes when you asked them a yes-no question. Okay? If you ask your sample group a question that produces a numerical answer, your data from the sample group will be a list of numbers. You can put those numbers into your calculator and find a mean or standard deviation, right? So in the case of this question here, they've used the word mean a few times, all right? So you can see the mean number here. Standard deviation. This is a question about means here. And why is it about means? Because the question that each bricklayer was asked is how many bricks did you lay per hour? Okay, so it's a numerical answer. So the symbols here are going to be mu, the population mean, and x bar here. If it was a yes-no question, the symbols would be p up there for the population and p hat down here. But in this case here, we're dealing with numerical data, so it's mu and x bar. So first of all, identify how many are in your sample group. That's your value for n, and then pick your symbols. Is it mu and x bar because the question is about means, or is it p and p hat because it's about proportions, right? Now, grab the results from your sample group, because they're the numbers you're going to do calculations with. So what are the results from my sample group? Well, we're told the mean number of bricks was 51, so x bar is 51, right? And the standard deviation, sigma, is 19. There we go. So I grabbed the results from my sample group like that. Finally then, if you're not doing a hypothesis, that's all the information you need, that's all the information you'll be given. But if you're doing a hypothesis test, there will be a number you want to compare your sample group to. Okay, there should be a number there I haven't used yet, which there is in this case here, the 48, that number up there, that's the one that goes up the top here. Okay, so in a hypothesis test, when you've pulled out the results from your sample group, if there's a number in there you haven't used yet, that's your value for the population. Now I'm done with the text, so I don't need to reread the text. So I can do my hypothesis test now. So remember, when you're doing a hypothesis, the first thing you want to do is write down your null and alternative hypotheses. And that's when you guys get a bit jumbled up when you try to write that as a sentence. I wouldn't bother. Okay, when I'm writing down my null hypothesis, I will always just use this. Whatever I put up there in my sketch, that'll get me full marks as my null hypothesis. So my null hypothesis, H0, is that mu is 48. If there were units, I'd put them in, but they're not. This is just a number of bricks, and bricks are not a unit of measurement, so I don't need to include those. But if, for example, it was minutes or centimeters or euro, I'd put the units in there just to be safe. All right? And then my alternative hypothesis, remember, HA, is that it's not equal to 48. Equal to or not equal to, they're my two hypotheses. Right? So whatever. So when if you've done that little sketch there where you can see whatever you have up here at the top of your sketch, that'll do as your null hypothesis in mathematical language. Now do your calculation. So remember, you can find your 95% confidence interval if you want to. You could find the Z statistic, or you can find a p-value. Now, I'll just talk about that a little bit now in a second. If I'm dealing with proportions, if it was a p and p hat, the only calculation I can do now is to find the 95% confidence interval and check if that number there is inside it or outside it. That's how you do a hypothesis test calculation if you're doing proportions. You just find your 95% confidence interval and check if that number is inside or not. If you're working with numerical data, as we are here, with means, there are 3 different calculations you can do, and that's what creates confusion. I've no idea which calculation I should do. I'm looking at the past exam questions. In one question, he does the p-value. In another question, he uses this z statistic. Sometimes he uses the 95% confidence interval. I have no idea why. Okay, there's nothing in the question that tells you that. They're just 3 versions of the same calculation. So when he doesn't tell you otherwise, you can choose any one of the 3. They're all going to give you the same result, right? So in this case, if I want to find my 95% confidence interval, remember, it's the result from my sample group, which is x bar, right? Plus or minus that number 1.96, which we mentioned in the previous question, is what makes this a 95% confidence interval. Okay, that's the z value that 95% of the data lies between, all right, times the standard error, and the standard error formulas are on page 34 of your formula booklet, okay? So the standard error formula looks like that. It's on page 34. Okay, so that's how I find my 95% confidence. It's the result from my sample group, x bar, plus or minus 1.96, the number that never changes, because that makes this a 95% confidence interval. It's the only one in the Leaving Cert course, times the standard error, the formula for which is on page 34. And all you do is fire the values in. So I get 51 plus or minus 1.96 times sigma is 19 over the square root of 85. Just fill the values in. And if I do the calculation there with a minus sign, I'll get the lower value. Okay, so doing with a minus sign there gives me 47. Doing the same calculation with a plus sign there gives me 55. And my interval is that the true value for mu is somewhere in between those two. So I just pop those numbers in. And all you got to do now, remember, you've got 3 lines. So according to my sample group, it looks like that the mean number of bricks laid per worker is somewhere between 47 and 55. The government body are claiming that it's 48, and that looks fine by my guess, yeah, because 48's inside that range, so there's no reason to think anything weird's going on here. There's no reason to reject the null hypothesis. So I just have to write down 3 lines out to finish the question. What you do now is you check, is the number you have here, the number that was given for the population, that number there, is it inside your interval or not? It is. 48 is between 47 and 55, so I'll mention that. So mu equal to 48 is inside the 95% confidence interval. Right? So mention it's inside the interval. It is between 47 and 55. And because it's inside, remember what that means is you fail to reject HO. If it's outside, you reject. If it's inside, you fail to reject HO. Now, I would stick to doing it that way. Again, if you've kind of done any of these kind of questions with me before, will have heard me say that. There are other ways you can phrase that, but sometimes they're right, sometimes they're not. That'll always be correct. Keep it simple. If it's inside your interval, it's always correct to fail to reject HO. If it's outside, it's always correct to reject HO. Keep it that simple. Simple, I should say, right? And then what does that mean as a conclusion? Remember that H0, the word null means nothing. So the null hypothesis is the assumption that there's no change or no difference. Think of it in those terms there. That's how I would always think about this, that H0 is the idea that there's no change or there's no difference. Okay, what that means will vary from question to question, but that's fundamentally what a null hypothesis is. The idea that there's no change and no difference. Right? So if you reject H0, you're concluding that there is a change or difference. If you don't reject H0, you're concluding that there's no change or difference here. Right? So because I failed to reject H0, I'm concluding that there's no difference. There's no difference between what my sample group said and what the government or the regulatory body said would happen. So there's no evidence the claim is false, or there's evidence the claim is true, or there's no reason to think the 48 is bullshit. Anything along those lines there. The key idea is that there's no reason to doubt the claim made there. My results suggest there's no difference. There's no change. There's no difference. There's nothing strange going on. There's no evidence the claim is false, or the claim looks okay. Don't say anything certain. Don't say the claim is true. You can't say that based on asking only 85 people. You just, again, have to soften the language there, but there's no evidence the claim is false. Now, that's how you do any hypothesis test. So if you pull out the information like I did there, write down your 2 hypotheses, your null and alternative, which will always just be whatever you've sketched up here in your diagram. Okay, that'll always serve as your null hypothesis. Do your calculation, then just check, is the number inside or outside the interval? Reject or don't reject H0, and then try and draw your conclusion. All right? Now, part 2 there, the p-value. I wouldn't rule that out this year, asking you to find a p-value. Right? So you can only find p-values when you're working with numerical data, when it's all about means. There's no p-value when you're working with proportions, because you don't have the formulas for doing it. So when you're doing a mean calculation, you can find a p-value, okay? And there's 2 steps, one of which we did already. First of all, what I'm going to do is I'm going to use the information from my test to find the z value, like we did in the previous question where we did a sample group of 139. We've got a sample group of 85 bricklayers here. Find the z value, exactly like we did in the previous question, using the formula from page 35. So with that formula there, it's x bar minus mu divided by sigma over root n. You're getting the z value for a group, because you've got a group of 85 here, and you've got all the symbols you need there. Notice that the 4 symbols there are the 4 things I have values for. Okay, so if you look at your sketch up there, that's exactly the 4 symbols I have values for. Okay, from the top there. All right. So it's 51 minus 48 all over 19. Standard deviation was 19 over the square root of 85. And that comes out as a z value of 1.46. So remember, if you were doing your hypothesis test using that number there, I'd be checking, does that number lie between plus and minus 1.96? It does. Why? Because 48 is inside my 95% confidence interval. It's the same calculation. Okay? So if the number is inside your 95% confidence interval, then that z value will be between plus and minus 1.96. They're just 2 versions of the same calculation. Okay? So the reason that number lies between plus and minus 1.96 is because 48 was inside my 95% confidence interval. So I can use either one of those. I could have done this calculation instead in the early part of the question, and now said because 146 lies between plus and minus 1.96, fail to reject H0 and draw my conclusion. They're just 2 versions of the same calculation, right? So the last part to find the p-value, remember that in the previous question, what did we do? We found the z value. We looked it up in the tables on page 36-37. So just do the same with this one here. Look up that value. So because it's a z value, look it up in your tables and see what happens, right? Because if you can imagine, there's the curve from page 36-37 with 0 in the middle like that. If I put the number 1.46 in there and find that bit there, which is just a z value calculation of the one we just did, and get the negative one as well. Mention that now in a second, just before we abandon it. Get what's below minus 1.46, that's your p-value. Those 2 shaded bits added together is your p-value, right? So if I just take 1.46 and look it up in the tables like we did in the previous question, I get 0.9279. So if you just look that number 1.46 up in the tables, just like you would normally do for a z value, again, like I did in the previous question, does that match my shaded area? No. That number is a lot bigger than 0.5, and my shaded area is less. So to get this bit here, subtract from 1. So 1 minus 0.9279 gives you 0.0721. So that little shaded bit on the right-hand side there is 0.0721. And because the curve is symmetrical, so is that. So your p-value is just those 2 added together. It's 0.0721. Plus 0.0721, which is 0.1442. That's how you find a p-value. So you just use the formula from page 25 to find the z value, look it up in the tables, subtract it from 1, and double your answer. That's how we find a p-value. Okay? It just hasn't asked that p-value calculation since what, 2021? Okay, so it's been a while now since the p-value came up it was on the deferred paper 2022, but he hasn't asked now in the main paper in a while. Just have it at the back of your memory. He could ask you to find that. And remember, if you were using that one to draw a conclusion, you're comparing it to 0.05. 5% level of significance as a decimal is 0.05. Okay, and remember, if p is below 0.05, you reject HO. If it's above, you don't. So again, see the way it gives you the same result I had anyway? That number is above 0.05, so we don't reject HO. Remember, if P is below, HO must go. So if P is below 0.05, you reject HO. Okay? If it's above, you don't. Okay, but those 3 calculations, your 95% confidence interval, your Z value, or your P value, they're just 3 versions of the same calculation. They will all give you the same result in terms of rejecting or not rejecting HO, so it doesn't matter which one you do unless the question specifies. He won't specify to do a hypothesis test using a Z value or something, but he can ask you to find the Z statistic or find the P value, and then maybe say hence or otherwise do a hypothesis test. So he can ask you to do one of those calculations specifically, but he won't specify which one to use in a hypothesis test. That's up to you. Okay? Now that's your stats. So normal distribution, maybe scatter plots and hypothesis testing and potentially p-value. Keep those at the back of your mind as potential questions for statistics. Okay, so that's two big hitters, stats and trigonometry. So the other big hitter we have a look at before we take another kind of short break, and I'll just do the three shorter ones, the line, the circle, and the geometry then to finish up the class. We'll have a quick look at the probability, right? So probability, again, is one that's very bitty. Okay. Now, the first probability question I'll do is question 4. Right, page 11. So, I suppose the banker in probability is Bernoulli trials. Okay, we'll have a look at that. There's a question coming up now with Bernoulli trials. And again, remember, Bernoulli trials can be asked as a kind of a single self-contained short question, or it can actually come up as part of a question with something else. All right, we'll kind of have a look at that now. Okay, but this one here, question 4. This is permutations and combinations. And remember, the key difference between them here is whether order matters or not. Okay, so if order matters when you're doing a calculation like this, it's a permutation question. And I tend to do that with the hangman method, as I remind you now. If order doesn't matter, it's a combinations question. And I'll do that with the NCOR button on my calculator. The one that got a nice workout on Friday when you were doing your binomial theorem. All right, so the binomial coefficient button NCOR. That's kind of keep it that simple. There are other ways of doing it. You can do it with factorials. Okay, you can do it with NPR button. There's lots of ways of doing this. I want to keep this as simple as I can, so I'll make that distinction. If order matters, it's a permutation. Remember, another word for a permutation is an arrangement. So just watch out for the verb arranged. Okay? Another word for a combination is a selection. So again, watch out for the verb select. Okay? So you can see here it says a box of 18 used books is donated to a charity shop. 10 of the books are science fiction, 5 are crime, and the rest are romance. Right? The charity shop owner wants to select. Okay, so order doesn't matter here. Okay, he just wants to get the order he picks them in doesn't matter. He just wants to select a set of books. There are 6 books from the box to display across a shelf in the shop window. How many 6-book selections are possible? So again, selection means order doesn't matter here. It just matters which 6 books he ends up with. All right? So because it's a selection, order doesn't matter. It's a combination question. I'll just use the NCOR button. So I've got 18 books to pick from, and I'm choosing 6. So it's 18C6. Remember using the NCOR button of your calculator like that, 18C6, and that's 18564. Okay, that's my answer there. So that's just done. So again, the key thing to watch out for the verb select. Remember, you select a team. So it doesn't matter what order you pick the players in. All that matters is which 11 players you end up picking. All right? So if you're selecting a team, the order is irrelevant. So selection means order doesn't matter. That's NCOR. It's a combinations question. Now, if you're dealing with a restriction then, all you're going to be doing when you're dealing with combinations is you're going to be putting that group of 18 apart into smaller groups and saying how many do I have got to pick from each group to give me the requirement of the question. So what part 2 says, how many of the selections contain 2 of each kind of book? So we're picking 6 altogether. How many selections contain 2 of each kind of book? So instead of thinking of the books now as a single group of 18, break them apart like this, right? So we've got a group of 10 science fiction books. We've got a group of 5 crime books. And then for a total of 18, that means there's 3 romance books. Okay, so there's 10 science fiction, 5 crime, and then there's 3 piles of shite to finish off the box. Okay? So what you want to do is you want 2 of each. So it says how many selections contain 2 of each kind of book. So I want 2 of the 10 science fiction books. I want 2 of the 5 crime books. And 2 of the crime books. That's all you're going to do when you're dealing with a restriction. Pull the larger group apart into smaller groups. And how many do you want to pick from each group to give me the requirement of the question? So that's just going to be 10C2 multiplied by, you multiply them together. Okay, so it's 10C2 multiplied by 5C2 multiplied by 3C2. And that comes out at 1350. There's your answer there. That's how we deal with restrictions when you're dealing with combinations. And the last part then, how many selections contain, now just be careful here, contain more crime books than books which are not crime? He has to say that contains more crime books than any other is a little bit awkward. Right? And I'll show you why now. That it's very clearly phrased here, crime books and books which are not crime books. Because if you think about that, there's more than one way we can accomplish that. Right? If you again think about the group of books broken down like that, right? We've got 5 books that are crime books and then 13 that are not. You see the way if he said more crime books than any other, I'd maybe have to pull the 13 apart into the science fiction, the romance, and maybe look at those as well, because if you've got 3 crime books, 2 science fiction and 1 romance, that works. I'd have more possibility to think about here, but no, it just says they're either crime or they're not crime books, right? So I've got 5 crime books and 13 that aren't, and I need to have more crime books. So I can't pick 3 of each. Okay, so what I could have 4 crime books and 2 of those. That'll work. So 4 of the 5 crime books and 2 of the ones that are not crime. That'll work. And if I do the calculation there, that comes out at 390. It's just 5C4 by 13C2. That's 390. But I could also do this, couldn't I? I could also say, look, how about I take all 5 crime books and just 1 of the romance, or sorry, 1 of the other ones. Okay, that'll work as well. And that comes out at 13. So the total number, if I just add those together, I get 403. Now, just remember, why did I add them there? Just remember in probability that and means multiply, or means add. Okay? So and, the word and means multiply, and the word or means add. So see how that works out here? So what are we saying here? Look, I take 4 of the 5 crime books and 2 of the 13 non-crime books. That's why I multiply those 2 together. The and means multiply. Or I take 5 of the crime books and 1 of the 13. So that or in the middle there means add. That's why the answer is 403. That's how we deal with combinations, right? Fairly straightforward using your NCOR button of your calculator, right? When we get to part B of the question then, it says the owner selects 6 books consisting of 3 science fiction books, 1 crime book, and 2 romance. Okay, so 3 science fiction, 1 crime, and 2 romance. In how many different orders? See the way, so we're talking about putting them in different orders here now. So this is a permutations question we're dealing with. There's a mention of order. Order matters here. Okay, so watch out for the clues in the question. Okay, the words he uses pushing you in the right direction. So many different orders can they be displayed? And so again, in this case here, I would just think like, look, there's 6 slots to fill here. So I've got 6 spaces across the shelf here. Which book goes first, which goes second, and so on. That's why it's called the hangman method. You've got 6 slots to fill like this, right? So any of the 6 books can go first. Then once I put a book first, there's 5 left. Any of the 5 can go next, so on. Then 4, then 3, then 2, then 1. And I just multiply all those together. Because remember, that's an and. I choose a book to go first, and choose a book to go second, and a book to go third, and so on. And if I multiply those out, I get 720. So those 6 books can be put in 720 different orders. Order matters here, so it's the hangman method. Now, the reason I like the hangman method here is because, remember, it means that if there's a restriction, I can deal with the restriction first. So there's no restriction there. It says, here's your 6 books. Put those in any order you like on the shelf. There's 720 different orders I can put them in, right? When I get to part 2, it says how many different orders can the 6 books be displayed if the romance books are to be placed at either end of the shelf, rather than in the bin where they belong. All right? So in this case here, the 2 romance books at either end. So again, I'll deal with the restrictions first. So I've got my 6 slots to be filled. And the restriction applies here and here. The first and last slots have to be filled with romance books. Right? So you've got 2 romance books. Remember, any one of those 2 can go here at the beginning of the shelf. And there's only 1 romance book left to go at the end. So there's the 2 romance books positioned at either end of the shelf. I've only got 2 choices there. Now, there's 4 left. I can put those any order I like in the middle. So I just go 4 by 3 by 2 by 1 in the middle like that. And multiply them out. So the benefit of the hangman method allows me to deal with the slot the restriction applies to first, and just fill the others any way I like, and that's 48. They can put in 48 different orders. And now I like the last part, part 3. So part 3 there says, in how many orders can they be displayed if the 3 science fiction books are not all to be placed side by side? Now, be careful of the phrasing there. It does not mean they all have to be separate. It just means you can't have all three side by side. You can have two side by side, you just can't have all three. That's important. Okay? So you're not allowed to have all three side by side means they just can't all be together. Two of them could be, you just can't have all three side by side. Now, the best way to do that one is to work out how many orders are possible where they are side by side. So if you're asked to find the ones where they're not all side by side, find the number where they are side by side first, and then take that from the total we found in the previous part of the question. Right? So how would I find the number of ranges where the three are side by side? Well, there's two steps to that. If you want the three science fiction books to stay side by side, imagine gluing the three of them together. So if I glue the three science fiction books together, treat them as a single book, that means they can't be separated, right? So that means you've got your three science fiction books now and the three other books to go on the shelf. So now think of it as in your head, there's only 4 books now. There's the 3 science fiction books which I've glued together to make a single book out of, and then I've got the other 3, the crime book and the 2 romance ones, right? So now there's only 4 books to be arranged, not 6. I'm treating the 3 science fiction books as a single book because I've glued them together. So I want to arrange those first of all. Okay, there's 4 slots. So 4 by 3 by 2 by 1. So if you treat the things that have to stay together as a single object, glue them together as a single object, so those 3 books become a single object. Now I've only got 4 to rearrange, and that gives me 24. Right, that's the first piece of the puzzle. But remember, when you're gluing the 3 science fiction books together, there's more than one order you can glue them in. Right? So if you maybe say you've got 3 books A, B, and C, I can glue them together in the order A, B, C. I could also glue them together in the order A, C, B, or B, C, A, because order matters here. So the order I glue the 3 books together in matters as well. So now what I want to work out is how many different orders could I glue the books together in? And that's just 3 by 2 by 1, yeah? You're going to pick one of the 3 books to go first, then one of the 2 to go second, and so on. So 3 by 2 by 1 is 6. And I multiply those 2 together, and I get 144. So if you're dealing with a question where particular things have to stay side by side, okay, the 2 things you want to do are treat the things that have to stay side by side as a single object and rearrange the objects, and then ask yourself how many ways could I have made that object in the first place when I'm gluing things together, and then I multiply the 2 together. So there's 144 arrangements where the 3 books are side by side. So if you take that from your total, you'll get the ones where they're not, and the total was 720 from the earlier part of the question, like that. So that's a nice question because you can see there's lots of bits to it. And every one of those calculations I do correctly will get me partial credits, get my score moving. If I get them all, obviously I'll get full marks. But it's kind of not hard to get at least some or most of those marks, okay, generating a good bunch of them. Right, next question then, this one here, all right? Just a very quick Venn diagram question. Now, actually, a lot of students have asked me about this now the last kind of couple of weeks, just because it seems like there's a lot of rules here. There's really only 4, if you want, formulas I would be using for this type of probability when I'm working with Venn diagrams. There's 2 rules and there's 2 definitions. Okay, that's all I would have at my disposal, right? So the things I'd know here, first of all, the union one. So the probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. And just remember, union here means or, and the intersection means and. Okay? So that one there, the probability of A union B is the probability of A plus the probability of B minus the probability of the intersection. Remember, that removes the double counting. Because in your Venn diagram, remember, if you've got 2 overlapping sets like that, that's A there, that's B there. There's the intersection in there. And if you just add the 2 sets together, you'd be counting that region twice. So we subtracted there to get together find that. That's one of the rules I'd know. And I'd also know the rule for conditional probability. Remember this one here. The probability of A given B is the probability of both of them above the line, A intersection B above the line, and whichever one is second goes below the line. Right? There we go. Now, they're the 2 I would know. They're the only 2 kind of formulas I need to answer questions like this. Okay, the union probability and the conditional probability formulas. If I've got those 2, I'm in business. The other 2 things I'd have are not rules, they're definitions. Right? So there's 2 kind of mathematical definitions I'd use as well. Okay. First of all, the definition for mutually exclusive. Right? What does it mean? Remember, mutually exclusive means the 2 things can't happen at the same time. And what that means is the probability of A intersection B is 0. So that's not a kind of a formula you're going to use. That's a mathematical definition. So if you like, the probability, the overlap, the bit in the middle here is 0. There's zero chance of both of these things happening. So that's a definition, not a rule. And the important one is the one for independence. Okay, if two events are independent, it means the probability of A intersection B is just the probability of A times the probability of B. Now, if you've got those four, that's your toolkit for this kind of probability. Okay, you don't need any more than that. Okay, so you've got those four in your toolkit, that's all you need. And you can see with those four now, I can sort this question out very, very quickly. So those two rules and those two definitions. Okay, if you've got those, that's all you need for this kind of probability. So if you look at the top of what we've got here, it says A and B are two events such that the probability of A is 0.24, probability B is 0.75, and A union B is 0.81. Find A intersection B. Well, happiest of happy days. Look at that formula there. I've got that formula there, and I know three of the four numbers. I'm asked to find the fourth one. Doddle. And you will certainly here, because that's a formula that's not given in your formula booklet, writing that down should get the partials. Okay? So if I've got that, I'm in business. And just fill in the numbers. So I know that A union B is 0.81. Probability of A is 0.24. B is 0.75. Minus the one I'm looking for. Okay? So if you move these two over onto the left-hand side, you get a minus 0.18 is equal to minus the probability of A intersection B. So just cancel the minus signs. 0.18 is the intersection you're looking for. So you can see the only difficult part there is, did I have the formula? So those two formulas are not in the formula book. That's all I've got to make sure I've got. Okay, so those two formulas, those two definitions were in business. Because look at part two now. Part two is one of those things that you've got to be careful of. Are A and B mutually exclusive? Explain your answer. I hate when he asks that. Explain your answer, because you guys tend to try and write an essay. You turn this now into English paper 3, so you're going to fill a whole paragraph there trying to describe here's what mutually exclusive means, and here's why I think. I don't care. You don't want to write it, I don't want to read it. Okay, it's very simple. Are they mutually exclusive? No, because probability of A intersection B is 0.18. It's not 0. Okay, so this is to avoid the last train to Wafflesville here. If I can just use my definition, right? So I'll just tell them the probability of A intersection B is equal to 0.18. It's not equal to 0. Therefore, they're not mutually exclusive. That's what that's used for. It's a definition. Okay. So don't kind of say, look, what I'll do is I'll spend the next 5 minutes telling you I know what mutually exclusive means. That's nice. Don't care. 0 marks. And that's what I asked you. I asked you, are they mutually exclusive? All I want to see is why. Okay, so your definition does that, right? Same with the next part. Okay. Show that A and B are independent. Again, see if I've got my definition. So what do I know? Probability of A intersection B is 0.18. We had that already. Let's see what's probability of A times probability of B. Are they the same? Well, A multiplied by B, remember, that's 0.24 multiplied by 0.75. Just multiplying the two I was given there together, and that's 0.18. Yay! They're equal. All right? So if I just say that probability of A intersection B is equal to the probability of A times the probability of B, because that statement is true, therefore, they're independent. So that's why you have those two definitions. So you're not trying to write sentences explaining what independence or mutual exclusive means. He doesn't care about that. He just wants to know, can you show that if you've got those two definitions, it's very easy to do. Right? And then finally, the last part of that question, okay, part 4, and find, okay, there's the conditional one. Right? So if I've got my formula, remember, it's the probability of one intersection the other. So it's going to be B intersection A above the line. And below the line, it's whichever one is second, probability of A. And I have those two values, don't I? Because remember, B intersection A is the same as A intersection B. It's the same overlap. So that's the 0.18. The probability of A we know is 0.24. And when you multiply those together, you get 0.75. Now, a lot of you may remember there's another definition for independence, which will tell you that if the probability of B given A is the same as the probability of B on its own, they're independent. And if that's true here, the probability of B given A is 0.75, which is the same as the probability of B on its own. That's fine as well. I don't need it though. I don't have to have that in my toolkit. If you've got that, it's another acceptable answer, but I don't have to have that. I could do the question without it. It just means that I wouldn't need to do a calculation. I could say, look, I know that it's equal to probability of B, which is 0.75, and I get full marks. Okay, so that's your Venn diagrammy stuff. Now, the last kind of 2 bits of probability before we take a kind of another quick break here. This one here, question 6. I like this because this one bounces into Bernoulli trials. Take a quick look at this maybe, and then we take another short break. So question 6 there. It says a wheel of fortune, okay, is divided into 7 sectors of equal size. Why, again, think in your head why he's stressing that, of equal size. It means that when you spin the wheel, you're equally likely to land on any one of them. So landing on any one of those is equally likely. He normally says that it has no impact on your calculation because we'd have to assume it otherwise, but that's the reason that we can land any of these numbers with equal likelihood. Find the expected value. Now, that expected value is a very simple calculation. Okay, it's not hard to do an expected value calculation. Remember, all you're going to do to find the expected value is multiply every outcome by its probability and add them all together. Okay, so you multiply each outcome by its probability and add them all together. So I would just do it as a very simple table, right? So what are the outcomes? Okay, what are the probabilities of those outcomes? And then I'll just multiply them. Right? So when you spin the wheel, look at the outcomes here. You can either land on 5, 10, 20, or 50. So when you spin that wheel, they're the possible outcomes. They're the numbers you could end up landing on. You can land a 5, a 10, a 20, or a 50, because that's all there is in the wheel. Now, what's the probability of landing on a 5? Well, notice here that there are 3 segments out of a total of 7. Okay, so because you're equally likely to land any of them, the probability of landing on that one is 3 over 7. 3 and 7. So the probability of landing on a 5 is 3 of 7. So for each outcome, you work out the probability and you multiply the pairs together. What's the probability of landing on a 10? Well, you can see there's 2 of those out of a total of 7. So it's 2 and 7 there. Landing on a 20, that's 1 and 7. And then 50 is 1 and 7 as well. And notice those probabilities always add up to 1. They have to, because every possible outcome has to be included there. So the probabilities have to add up to 1. So what I do now is multiply each pair together. So multiply these 2 numbers together, multiply those 2 together. So multiply each outcome by its probability and add them all up. So 5 times 3 over 7, that's 15 over 7. 10 times 3 over 7, that's 20 over 7. 20 times 1 over 7, that's also 20 over 7. And 50 times 1 over 7 is 50 over 7. And if you add those numbers together and you're using your calculator, you get 15. So that's your expected value. Now what that means, remember, is if you were to spin that wheel over and over and over again a huge number of times, the average score you'll end up with is 15. You can't score 15 on any spin of the wheel because it's not a number of the wheel. We're talking about your average score over a long period. It's sometimes called the long run average. So if you were to spin that wheel over and over again a huge number of times, the average score would be 15. Right? So if they were sums of money, if you're winning that, it means on average players will win €15 every time that the wheel is spun. Which means in order for the game to be fair, they have to be paying €15 to play. So that it would balance out. You're going to players make as much money from prizes as they pay to play. Okay? So if the cost of playing was the same as that number there, the game would be fair. The expected value would be 0. Okay, so that's how you find expected value, right? Now look at the second part of the question here. If the wheel is spun twice, so if you spin the wheel twice, find the probability the sum of the scores of the 2 spins is greater than 25. There's one of those ones that ties you guys into a pretzel. How on earth do I do that? If you're spinning this wheel twice, what's the probability of me getting a score that's bigger than 25, right? There's a few ways you could do it. There isn't one single way. Here you just got to trust your gut. So what I could do, for example, is I could do what some of you might have seen as a two-way table, right? So if you think about it like this, that say, for example, on the first spin, right, I could get a 3, sorry, I can't get a 3. I could get a 5, a 5, a 5, a 10, a 10, a 20, or a 50. That's on the first spin. On the second spin, I could get a 5, a 5, a 5, a 10, a 10, a 20, or a 50. So there's the 2 spins like that. See it? I said, look, so how many possible outcomes is that? Well, look, you've got 7 across here by 7 down. That's 49 possible outcomes altogether. There's 7 possible sectors I could land on when I spin it the first time. and 7 I could land on when I spin the second time. So 7 sevens are 49 possible combinations altogether, right? Now, how many of those are bigger than 25? Well, if you get a 1 and a 50, that'll give you a score that's bigger than 25. 1 and 20 won't work. That's 25. It says greater than 25, so that won't work. Okay, 5 and 50 will work here. 5 and 50 will work here. 10 and 20 or 50 will work. 10 and 20 or 50 will work. 20 with the 10, the 10, the 20 or the 50 will work, and 50 with any of them like that. So I'm just ticking any of these where if I get this on the first spin and that on the second spin, which of those outcomes gives me a total that's more than 25? And if you add them up there, there's 18 ticks in the box, so it's 18 of the 49 possibilities. 18 over 49 is the correct answer. Now that's a really tricky question because it's not hard to do, but just it's hard to know how to go about it. It's not the only way to do it. I'll show you another way now. But that's the one that you guys have difficulty with. It's a little bit like, is it not, the problem that I'm sure that you guys had with question 10 on Friday. That actually the maths weren't too bad at all, but it was more like a puzzle you were solving. And it's not like I was using a method I've done and practiced in class. I had to try and spot something here, and I wasn't sure I was doing it right because it didn't feel like I was using a method here. Same idea with a question like that. There might be a couple of ways of doing it, all right? And I'm not sure, does that work? Another way of doing it is remember, to work out, well, how could this be accomplished? What combination of events would happen here? Well, if I get a 5 on the first spin, okay, and at 50 on the second spin, that'll work. Yes, so if I get a 5 on spin number 1, a 5 on spin number 2, that's 55, that'll work. Now, what's the chance of getting a 5 on spin number 1? Well, if you look at your wheel, 3 of the 7 segments are 5s, so that's 3 over 7. It's the probability of getting a 5 on the first spin. And what's the chance of getting a 50 on the second spin? 1 in 7. So I multiply those two together, like that, I get 3 over 49. So there's one combination of events, getting a 5 on the first spin and a 50 on the second. Now, there's partial credit all day long. That's probably even high partial, because you've not only identified 2, you've identified a combination that'll work, but you correctly identified the probabilities and you know to multiply them together. But that's not the only sequence of events that'll work. I could also, couldn't I say, well, look, if I get a 10 on the first spin and a 20 on the second spin, what's the chance of getting a 10 first time out? That's 2 out of 7, because it's 2 out of the 7 segments, and again, 1 over 7 and so on. That's 2 over 49. And you can see what you're doing is you're working these out individually. So see that 3 over 49 there is those 3 there. 3 where you get 5 first, see it? That 2 over 49 there is 10 first and 20 second. That's those 2 there. Okay, sorry, that's those 2 there. And see, so I'm actually just working them out by calculation. I could the same say for 10 and 50. Okay, I could say do 20 and 10, 20 and 20, 20 and 50. All right, I could do 50 and 5, 50 and 10, 50 and 20, and 50 and 50. So I could do it that way and add them all up. It's the same idea. But that's one of those where you're going to feel like, I feel like I'm making shit up here. I'm not really doing something. You're not. You're doing it correctly. Just trust your gut. So don't expect everything I say where you just fall into a method I've practiced. It might just be try to make sense of it and put something down and see how far you get. But the answer there is 18 over 49. That's the correct, either a two-way table or by multiplying out probabilities, whichever way you find makes most sense to you. Okay? And then the last part of the question, part B then, here's your Bernoulli trials. Okay? So you want to make sure you've got your Bernoulli trials in your back pocket for sure. Okay? So it says the wheel is spun a total of 6 times, one after the other. Now, when you're repeating an experiment 3, 4, 5, 6 times, the only method we have in probability for dealing with something that's repeated that many times is Bernoulli trials. You can't do a tree diagram for that many. And you couldn't start multiplying out probabilities for that many steps and then working out all the possible combinations. So if you're dealing with something that's repeated 3, 4, 5, 6, 7, 8 times, that in your head should push you towards Bernoulli trials, right? And the formula, remember, is on page 33 of your formula booklet. So the binomial distribution formula is on page 33 of your formula booklet, all right? So in this case, it says find the probability the wheel lands on 5 exactly 4 times, right? So what's the probability that we land on a 5? So the probability that you land on a 5, remember, is 3 out of 7. Right, that's probably that we get a 5 from looking at the wheel, which means the probability that we don't land on a 5 is 4 over 7. Remember, the two probabilities have to add up to 1. So there's a 3 in 7 chance you do, so there's a 4 in 7 chance you don't. So if I just fill in my formula, remember that n is the number of trials, that's 6. Okay? And if I just put down the two probabilities, 3 over 7 and 4 over 7, right, like that, there's the two probabilities, which always add up to 1. We're trying to find the probability that we land on 5 exactly 4 times. Right? So that's a 4 in there. And just remember, if that's the probability you land on a 5, that's the number of times you land on a 5. And if that's the probability that you don't land on a 5, that's the number of times you don't land on a 5. So don't kind of worry about the or and n minus or from the formula booklet. Okay, that the power is the number of times that happens. So if 3 over 7 is the probability of getting a 5, then the power is the number of times you get a 5. So we want to get 4 of those. So you want to land on a 5 4 times, all right, and then not land on a 4 twice. See why those two numbers have to add up to 6? Because all 6 spins have to be counted there. So we land on 5 4 times, and we don't land on 5 twice. So if you just blast that into your calculator and push a couple of buttons, it'll decimalize that, which is fine. That comes out at 0.165 or thereabouts, or 0.17. I'm just going to argue with that, over that. Okay? So that's how you use the Bernoulli. So again, the clue that's a Bernoulli trials question is the fact that I'm repeating a trial 4, 5, 6, 7, 8 times. The only kind of method we have in probability for dealing with something that's repeated that many times is Bernoulli trials. So start moving in that direction. Right? Look at part 2. Okay, so we just finished this question, but then we take kind of one more break before we just put the final push in, have a quick look at the geometries to bring us up to the end. So part 2, find the probability the wheel lands on 10 less than 5 times. Now look what happened here. We're changing now to looking to landing on 10, not landing on 5. Asked you in an exam, would you have gone with 3 over 7 and 4 over 7 probabilities again? You're not. So in the previous question, we were tracking landing on the number 5. Now it's a separate question, we're landing on 10 this time, right? So this time, remember, the probability of landing on a 10 is 2 over 7. And the probability of not landing on a 10 then is 5 over 7. Right? So it's not 3 over 7 and 4 over 7 because we're looking for landing on 10 this time, not 5. Watch out for that. So if you land on 10 less than 5 times, so think about this for a second because it'll be helpful when we get to the part 4 of the question in a moment. If you spin the wheel 6 times, how many times could you land on 10? Well, you could land on 10 0 times, or 1, or 2, or 3, or 4, or 5, or 6. So if I spin the wheel 6 times, there's the number of times I could get a 10. I get a 10 from not getting any 10s at all the way down to getting 10 every time, right? If you were to work out this, the probability of landing on 10 0 times, and then do this calculation here with the formula, the probability of landing on 10 once, and twice, and so on, if you add all those numbers together, you get 1 as a total. So when your list includes every possible outcome, the probabilities have to add up to 1. Right? Now, what am I looking for in this question here? Okay, in this question here, I'm looking for the probability that we land on 10 less than 5 times. That means 0 times, or 1, or 2, or 3, or 4. That's what we're looking for. Less than 5 times means 0, 1, 2, 3, or 4. Right? So what that means is I want to know what those 5 numbers add up to. The probability of landing on it 0 times, or once, or twice, or 3 times, or 4 times. That's what less than 5 means. So I could do those 5 calculations there, add them all together, full marks. Perfectly fine. Do you see the way it's slightly quicker to do the workaround? That's why I'm kind of pointing this one out here. Would it not be quicker to find the probability of these two here and subtract from 1? There's my workaround. That's why that's a nice exam question, because if you don't spot that, it doesn't matter. You guys still get to do the calculations, do 0, 1, 2, 3, and 4, add them all together, you get full marks, perfectly happy. But if you spot this, it just saves you a little bit of time, all right? So if you look at this one here then, so the way I would do this one then, I'm going to find the probability of 5, landing on it 5 times. So again, there's my long thin bracket, there's the 6 like that, and my probabilities here are 2 over 7 and 5 over 7, right? And to make it happen 5 times, I'm going to put a 5 here. Right? And then we land on 10 5 times, which means we don't land on 10 once. Okay? And if you put that in, it's a small number. It's 8.2 by 10 to the minus 3. You can leave it like that. No need to turn it into a vulgar decimal. It comes out in scientific notation. Leave it that way. That's that number there. And do the same for the 6 then. Find the probability we landed 6 times. It's 6C6, like that. There's your 2 probabilities. Right? And we land on 10 6 times, which means we don't land on 10 0 times. And that's an even smaller number. It's 5.4 by 10 to the minus 4. That's what that number there is. So if I subtract those two from 1, Robert's your mother's brother, we've got our answer, right? So 1 minus 8.2 by 10 to the minus 3 minus 5.4 by 10 to the minus 4. You don't even need to put those in brackets, because the order of operation will do the multiplications first anyway. So you can just type it in like that to your calculator, and you get 0.991. And that's your answer. So when you're dealing with this at least or at most type question, you're just going to be using the calculation with the formula a couple of times and adding them together, or maybe a couple of times and subtracting them from 1 if you spot that as a workaround, if it helps. right? Now, the last two then, just to kind of bring us into the break, just to finish up, make sure you've got these two in Bernoulli trials. Number 3 and number 4 is becoming increasingly popular, okay? Number 3, find the probability that the fourth spin is the second one to land on 20. Now, we won't ask for a show of hands. Who would have done this, right? Said, look, so at this stage, we've only had 4 spins, okay? So 4 spins so far. Landing on 20, the probability of landing on a 20 is 1 in 7. And so again, see the probability of changing because we're now tracking landing on 10s, sorry, on 20s. The probability of landing on 20 is 1 in 7. Probability of not landing on 20 is 6 in 7. And you're kind of saying, right, so what that means is that we've got 4 spins so far. 2 of them have been successful. So we've got 2 there. That means we had 2 of these, and you did that calculation there. Right? If you did that, you're going to get the low partial credit. Okay, he won't give you any more than that. That's wrong. It's not hopelessly, pathetically wrong. Okay, you're not incredibly dumb. You're just kind of low key. All right, so you're kind of in there because the calculation's not far off. The problem with that is what you're finding there is the problem that if the wheel has been spun 4 times, any 2 of them were 20s. It doesn't guarantee that spin number 4 is one of the 20s. Right? So if you read the question, what it means is we do score a 20 on spin number 4, and that's the second time we did that. So when you're doing that one there, take that last spin out of the picture. Spin number 4, ignore that one. We know that's a 20. What would have to happen on the previous 3? What that means is you land on 20 in one of the first 3, right? And then you land on 20 in number 4. That's how we make that happen. So in order for number 4 to be your second success, it means we had 1 success in our first 3, and then we were successful with number 4. That's how you pull that one apart. So this bit's done with the formula. Okay, so 3 so far. There's your 1 over 7, and your 6 over 7. All right, and if we've had 1 success over, that's a 1 there. That means 1 20 and 2 that weren't 20s. Right? So that's the probability that any one of the first 3 was a 20. And means multiply. What's the probability that you land on a 20 on spin number 4? Well, spin number 4 is just a single spin. That's just the typical the probability of success, 1 over 7. And if you pop that into your calculator, you get 0.045. So make sure you've seen that one there. A particular number of success on a particular number trial. Right? And then finally, this last one here. You probably remember this last one here. I've kind of had a chat about this guy already, okay? When he first asked this back in 2017, I'm sure if you've been with me this year, I've heard the poor old Connor question. Poor, desperate, needy Connor. You know, the short question from 2017 where Connor was ringing his girlfriend's house every day for a week. And the probability for answering this was getting progressively smaller, all right? So he says, how many times does Connor have to ring this woman? Okay, so the chance of her answering at least once is like 95%, and it's like 3 weeks or something. So Connor can't take a hint. Okay, Connor is going to be sitting at home in his Deb suit with nobody turning up here, sitting on his own. This one here is the same question. He's asked this now 3 or 4 times since. Okay, how many times do you have to repeat something? So the probability of getting 1 success is this. So watch this one here. As I said, for me, it's always now a likely one to follow in. So when he asked in 2017, he was so delighted with that question, he's put on the paper now kind of 3 times since. So find the minimum number of times the wheel would need to be spun. So the probability of landing on 50 at least once is greater than 95%. So again, suppose you spin the wheel over and over again. Right? We don't know how many times yet. How many times could you land on 50? Well, you could land on 50 0 times, or 1 time, or 2 times, or 3 times, all the way down to n, whatever n is. So if I spin the wheel n times, there's the number of times I could end up landing on 50. Now, we want to find the probability of landing at least once. That means we land at once, or twice, or 3 times, or 4, all the way down here. So I want to know what all those numbers add up to. Those numbers add together. That tells you what the probability is of landing on 50 at least once if you spin the wheel n times. Do you see the same workaround we had in the previous question? We know all of those probabilities add up to 1. So wouldn't it be quicker to find the probability that you don't land on 50 at all and subtract it from 1? That's how we do this one. So what's the probability of landing on 50 0 times if you spin the wheel n times? Well, if we use our formula, like that, we don't know what n is. We don't know how many times we're spinning the wheel here, but it turns out we don't need to. There's my 2 probabilities. So the probability of spinning a 50 is 1 in 7, and not spinning is 6 in 7. Right? So to find the probability that you land on 50 0 times, right, there's going to be a 0 there. That means we've got none of those, and we've got n of those. So every time we spin the wheel, we land a number that's not 50. So it's 6 over 7 to the power of n. Now, the good news, you can't put that into your calculator, but any number C0 is 1. So 2C0 is 1, 3C0 is 1. So it doesn't matter what n is, that's definitely a 1. Okay, because any number C0 is 1. And also, any number to the power of 0 is also 1. Yeah, so any number to the power of 0 is, so these are always both 1s like that. So we get 6 over 7 like that to the power of n. So that's your answer. Okay, that one there. So the probability of not getting any success at all is 6 over 7 to the power of n. So to find the probability that you get at least one success, subtract that from 1. So 1 minus 6 over 7 to the power of n. That's the probability that if you spin the wheel n times, you get at least 150. And we want that to be greater than 95%. Okay? So we want that to be greater than 0.95. 95%. I just have to solve for n. There's an exponential equation I'm going to solve there. Now, don't leave it as an inequality like that, because you're going to be using logs here, and inequalities don't behave themselves when logs are involved. If you take the log to both sides of a number that's less than 1, it's like multiplying by a negative number, the sign flips. So don't worry about having it as an inequality. Just treat it as an equation, find the value for n, then take the first whole number above, round up. Okay, always round up. Okay? So if I say, look, 1 minus 6 over 7 to the power of n equals 0.95. Find n and then just take the first number above that. Always go up. Always round up. Okay? So if I bring them 0.95 over onto the left-hand side, I get 1 minus 0.95 over here is equal to 6 over 7 to the power of n, that way. Right? And then, so the number on the you can see the number on this side here just basically becomes 0.05. And then you can just use logs now. See it? So remember that when you're solving logs, there's two ways people are taught to do that. Remember, if you're solving an equation like this, say 2 to the power of x equals 32. To leave the x by itself on the left-hand side, I want to get rid of 2 to the power of. And to get rid of 2 to the power of, I use log to the base 2. To get rid of 5 to the power of, I use log to the base 5. So in that case there, I would use log to the base 2 on the left-hand side like that. Because these two basis numbers here match, so they'll cancel. And leave the x behind. So I've got to go with log to the base 2 on this side here, which gives you, what, 5. All right? So that, you can use logs. Or you can take the natural log of both sides and divide. So if you're taught to do that, that's perfectly fine as well. So to remove 6 over 7 to the power of here, I'll use log to the base 6 over 7. So this side here, if I go with log to the base 6 over 7 on the left-hand side like that, sorry, the right-hand side, because these two numbers here match, they'll cancel. I just leave the n behind. So I've got to go with logs on this side here as well. Log to the base 6 over 7, 0.05. And that comes out at like 19.4. So we'll round up. N is 20. Take the first whole number above. So it means if you spin the wheel 20 times, the chances of you landing on 50 at least once is bigger than 95%. Now that's all the probability, all the things you need to be able to do in probability. Expected value, Venn diagrams, permutations, combinations, and Bernoulli trials. So we'll take one more little break there now, say for about 5 or 6 minutes, just final time, and then we'll come back and we'll just hit the last three, the short ones, the geometries and coordinate geometry. the longer, the bigger topics. Okay, we gave trigonometry a good look there, good look at stats, and a good look at probability. So the other topics then, remember, on paper 2 are your geometries and the coordinate geometry. Okay, so essentially it's the geometry strand there, geometry, coordinate geometry of the line, coordinate geometry of the circle, right? So, I mean, again, these now you're talking about are almost sure to be short questions. Okay, so the short question, this is kind of more likely to be short questions. You could get maybe a diagram-based question with a bit of area and volume in there as part of a long quest that might bring in the geometry. But certainly the line, the circle, I'd be expecting to see as short questions, one of each. And you might, as I said, get some kind of a shape-based question, maybe bring in some area and volume and trigonometry that might include some geometry as part of a long question. All right? So I'm just going to start very quickly first with question 11, because I just want to deal with the geometry first. That the obvious thing in geometry, a big part of the course in geometry, is your construction work and your theorems. Right? So the 3 theorems and the constructions, constructing the centers of a triangle in particular. Right? Now, he did ask, remember, one of each of those last year. He asked the centroid construction, and he also asked theorem 11 last year. Right? And I guess conventional wisdom is that he probably won't ask them again this year. And I think that's probably likely. I mean, he may give those a miss altogether. It just felt to me a little bit like he emptied the options box. When he had both those last year, there's not an awful lot left he could ask. All right? What I would be saying again is if you haven't done proofs or constructions at this stage, I don't see there's any value in going home this evening and trying to learn off constructions or learn off theorems. Okay, I don't see the value in that. Certainly, I think if you've been given advice that they're not likely, I would agree with that. I think they're not likely. They're not impossible. But I think you'll probably find better things to do this evening than sitting down to learn proofs or theorems at this stage. Okay, I think it's possible he could maybe throw a theorem on again. It's not impossible, all right, for him to throw a theorem on there. If I had to choose, I think he might do theorem 13, the one about similar triangles. But my feeling is you'll probably get a question of some kind that involves similar triangles, whether you prove it or not. So if you do kind of say, look, I didn't learn off any proofs or theorems, and a theorem or proof question comes up tomorrow, a construction question, don't panic. Okay, there's no reason to panic there. That I mean, I would imagine this year a lot of people will have left out the proofs and constructions because they were asked last year, which means a question with a proof of construction there would be probably very badly answered, which means the marking scheme would probably be tweaked to allow for that. So if hardly anybody answers a theorem well, they'll reduce it to maybe 5 marks. It's not going to kill your score if you're not doing it particularly well. So I wouldn't at this stage be panicking about stuff I don't know. I did say that kind of in my advice before paper 1, that the night before the exam you don't want to be freaking out and trying to look at stuff you feel you don't know. Consolidate and nail down the stuff you do. Right? But theorem 13, the one about similar triangles, is not impossible. I think it's probably more important for tomorrow that you know how to work with similar triangles. Okay, which is what I'm going to show you here in question 11. So question 11 is the one on page 31. Just a quick geometry question here, because you might get something along these lines here. And then we'll finish up the class by having a quick look at the coordinate geometries, the line and circle, just to finish up, if that's okay. All right? So question 11 here then, you can see it says, in the diagram of the circle C below, P, Q, R, and S, remember, elements of C means they're points on the circle C. Okay? So P, Q, R, and S are all points on the circle C. That's what kind of the elements of C there means, all right? So it says if PQ, remember there's your intersection symbol. So if PR and QS intersect the point T, it doesn't matter if I don't recognize that language because see it's on the diagram for me. So it just means if PR and QS intersect at the point T. Okay, prove that the triangles PQR and PQT are similar. Now remember, similar means that the 3 angles in one triangle match the 3 angles in the other. That one triangle is a larger version of the other. Okay, so the 2 triangles have the same 3 internal angles, just one triangle is a bit bigger than the other. That's what similar means, right? They're the same shape but different sizes. If the sides and angles were the same, the triangles are identical, they're congruent. Okay, so congruent means it's the same size and the same shape. The 3 angles match and the 3 sides match. Similar means the angles match but the sides don't. One triangle is a larger version. Imagine photocopying one and making it bigger. All right? So if you're trying to show that 2 triangles are similar, there have to be 4 lines. Right? What you've got to start doing is identifying pairs of angles in the triangles that you know are equal and say why. You've got to justify why as you're going along here. Typically for a question of this type, it's worth 10 marks. Right? So if you can identify any 2 angles that match, either on the diagram or in text, without saying why, you'll get 4 marks. You'll get 4 to 10. Right? If you can identify 2 angles that match without explaining why, you'll get 7. Okay? If you can identify any one pair that match with the justification, you'll get 7. And if you can do the whole thing, you'll get 10. So if you kind of feel, look, I'm not good at geometry because I'm never sure how to back it up or what to say to back it up. If you can do the calculation without backing it up, you'll get the highest partial credit mark. You get 7 out of 10. right? So the key idea here is I'm trying to find pairs of angles that match, and I want to try to see if I can say why in each case, right? So if you look at the two triangles, it's the triangle PQR. So PQR is this this triangle here. There's PQR. See it? So maybe you don't need to, but I'm just going to sketch that triangle here. There's PQR, right? That's this one. And PQT is this one, right? So you can see it's that triangle there. PQT, right? The smaller one in there. And the question is, can I show that these two triangles are similar? So can you identify either on the diagram or in text any angles that match? Well, the one that jumps out to me straight away is, if you look at this angle here, see that angle there? It's in both triangles. There it is there, and there it is there. So the two triangles have that angle in common because it's the same angle. So I'll put that down first. Remember, I'm thinking in my own head here that I'm looking for 4 lines. Okay, so I want to kind of say one pair of angles that are the same and say why. So what I'll mention here, you don't need to number them yourself, but I'm numbering them here. I'm going to say that the angle Q, what's it called? QPT. So I say the angle QPT. Now, I'm going to use the very formal language. I'm going to put the lines in and the angle symbol. Realistically, if you just write down QPT, he will generally give you full marks for that. Don't worry too much about the being very rigorous with the language. Is equal to the angle QPT. And my justification there is, it's the same angle. Okay? Now, that's 7 marks. Because I've identified a pair of angles that match, and I've given the correct justification. If I just write down the same, but I don't justify it, I've got 4. Okay, but I know those 2 angles match. Now, are there any other angles that I know match? Well, if you look at this, if I just piece this together in my own head, just piece together the logic here, look at the information given in the question. All right? So we're told that PR bisects the angle QRS. So this line here, PR, cuts that. So that angle there and that angle there are identical. So the angle QRS is this angle up here, and the line PR bisects it, right? So these 2 angles here, which I've marked kind of with the black dots there, they're the same, right? So here's the final piece of the puzzle if I want to get this right. If you remember, which a lot of students don't, if you remember that arc there, the arc PS, if I go from these 2 points here to the point Q, I've got that angle there. That angle is sitting on the arc PS. Right? So is that one. Because if I go from P and S to that point up there, so if you remember, if you've got a circle like that, and if I take 2 points like this, the piece of circle in between them, that's the arc PS. If I join those 2 points to any other point in the circle, suppose I join those 2 points at this point over here, right? That angle is sitting on the arc PS. If I join the 2 endpoints to an angle over here, that angle is also sitting on the arc PS, and they're always the same. So angles sitting on the same arc are equal. That's what I need to finish this one out. So again, you might not remember that. So you're kind of saying, oh, I'd never be able to do this question. Well, you won't be able to get full marks. But see, if I was just able to identify one pair of angles that match and say why, I get 7 out of 10. Okay? If I can identify the 2, so you can see what I'm going to say now, because if you look at the angles we're dealing with, I'm going to pick out this angle here first. Okay, that angle there, because that's this one. Right? So that angle up there, I'm going to take the angle QRT, right? So I'm going to say there, right, come on, there we go. So my second kind of line down here, the angle QRT is equal to the angle SRT. And the reason for that is that was given, because we were told that PS bisects that angle. So I know those 2 angles match. Okay, so QRT is the same as RST. Okay, or as SRT, I should say. What I'll also say then is, you see in my triangle, the angle PQT. Let me just show you that. Just, I hate having to bounce up and down. Okay. But the argument I'm making here, the geometric argument, is that this angle here, let me just use a different color for these 2. Okay. Right? So this angle here, that green one there, and this angle here match. Because I was told that the line went down the middle, this line here cuts that angle in half. So those 2 match, that's what I've written down here. I'm now going to say that this angle here and this angle here match. Because they're both sitting on this arc down here. Yeah? Therefore, this angle here and this one here have to match. That's a tricky geometric argument. It's very hard to spot. That I'm trying to show that those two angles, the two angles that I've kind of circled here, this angle up here and this angle in here, okay, that angle there, and let me just go back to black, this angle here, are the same. Okay, puzzle that out. But the point is there with the marking scheme, it's the same as I said with induction the other night, that a lot of people kind of say, look, it's very hard to get full marks in induction. If I'm trying to show the two triangles are similar, it's 10 marks. If I can just identify pairs of angles that match without saying why twice, I'll get 7 out of 10. If I can identify any one pair that match and say why, which should be easy, I'll get 7 out of 10. That's how I'm going to think about that. And the key thing, why is he asking me to show this? It's so you know the triangles are similar, because you're going to be using that in the next part of the question anyway, right? So that's the geometric argument I'm making here, all right? So I'm now saying I've already proved that those two are the same. So if I said that PQT is also equal to SRT, okay, because they're sitting on the same arc. Okay, that means these two have to match because they're both equal to SRT. So therefore, the angle QRT has to equal the angle PQT, okay, because they're both equal to SRT. And once you've done that, remember, doesn't that mean the remaining angle has to match as well? That when you're dealing with similar triangles, if two angles match, the third one must be the same to give you a total of 180. So I don't need to justify the third one. I can just conclude now with no further justification that the third angles must match well because the remaining angles in the two triangles. Okay? So the remaining angles then I can just write down as being equal as well. Let's keep saving here. Okay? So line number 3, I'll just say that the angle PQR, which is the remaining angle there, and the angle PTQ are also equal because they're just the remaining angles. I don't even need to justify that. Okay, and therefore the two triangles PQR and PQT, are equal. Okay, are similar. Okay, so I lost part of it there, but it doesn't make any difference. So remember, your last line there is that therefore the two of them are similar. So therefore, PQR and PQT are similar. That's your fourth line. So a line each for saying the three pairs of angles that match and why, and then your fourth line just saying therefore they're similar. Okay, so that will be difficult. That normally is. I mean, if you go back to the past geometry questions, he's asked that a few times to prove the two triangles are similar. That can be quite tricky. But it's the marking scheme that's important there. If I can just identify one pair of angles that match and say why, that's 7 marks. And the important thing is I know the triangles are similar, so I can use that in the next part of the question. Because the next part of the question then asks me to do something with the similar triangles. Okay? You can see the next part of the question here. It says, hence prove that PQ squared is equal to PT squared plus PT times RT. Now, I haven't a clue what to do with that yet. Here's the clue, though. He told me the triangles are similar. He told me the triangles are similar, right? So if you remember what the two similar triangles look like, you don't need to do this yourself, but if I just remember what the two triangles look like, okay, the two triangles we had there. So there's the triangle, just so I don't have to keep moving up and moving down here, right? There's one triangle there. There's the triangle PQR. And there's the other one, PQT. There's PQT. And the angles I proved are the same. I proved that that angle there and that angle there are the same. Okay? I also proved that that angle there and that angle there are the same, which means the remaining one, that angle there and that angle there match. There's my two similar triangles. Okay? They're the angles I showed were the same. Now, what that means is corresponding sides are proportional. That's theorem 13. Now, what do I mean by corresponding sides? Well, if you look at the top triangle there, in between the red and blue angles is that side there, right? In the other triangle, in between the red and blue angles is that side there. So those two sides are corresponding. They're between the same two angles, right? With the same argument, right? In between the black and blue angles here is that side. So in between the black and blue angles here is that side. The two green sides are corresponding. They're between the same pair of angles, right? And finally then, the remaining side that has to be the same. So in each triangle, so in between the red and black angles is that side there and that side there. So the two red sides are corresponding, the two green sides are corresponding, and the two yellow sides are corresponding. Now what that means is, if I take the two red sides, the two blue sides, and the two yellow sides and write them as fractions, all those fractions are equal. That's what you need when you work with similar triangles. So if you get a question where you're trying to show two triangles are similar, okay, even if I can't do that, this is where the question is going to go next. If you've got a pair of similar triangles, okay, if you do what I did there, even for your own benefit, use colour. Indicate the sides that are between the same pairs of angles. So I marked as black, blue, and red the pairs of angles that I know match from earlier on. Even if I can't explain why, I know they match. So you can see in between each pair of angles, I've kind of got a side. So in this case here, between the red and blue angles is QR. I marked that in red. And between the red and blue angles, the other one is QT. I marked that in red. So the two red sides are corresponding. The two green sides are corresponding, and the two black sides are corresponding. So what that means is, if I write the two red sides as a fraction, the two blue sides, the two green sides as a fraction, the two yellow sides as a fraction, those fractions are equal, right? So if I want to start off and just even write this down myself, okay, to begin with. So if I take from the top triangle there, okay, if I take, say, PQ, the yellow side, so say from the top triangle there, PQ is the yellow side. What's the yellow side from the bottom one? PT. So there's the two, if you like, you don't have to write this yourself, but there's the two yellow sides written as a fraction, okay? Look at the two red sides. So take the two green sides. We've got PR there is the green side from the top triangle, and PQ is the green side from the bottom triangle. And then that leaves you with QR, the two red sides, over QT. They're the red sides. Those fractions are all equal. So I just identify the pairs and write them down as equal. Now, if you give him that, he's going to throw marks at you now like confetti at a wedding. Okay? Because you've identified what I mean by similar triangles, you've picked up the corresponding sides, and you've written the fraction. That's worth high partial all day long. But if you see similar triangles and you're going to take on the question, I would do that. If necessary, if they're overlapping, I would draw the two triangles separately, mark in the angles that match, and then if you need to, in colour, mark the corresponding sides. Okay, which sides sit between the same two angles. And if you make each pair of same coloured sides as fractions, they're equal. Now all of a sudden, look what we've got here. Right? I mean, because you can see QT and QR, see these two guys here? They don't appear anywhere in my answer there at all. So I probably don't need these two. But look at the two I've got here. So if I take those two there, just PQ over PT is equal to PR over PQ. See, if I cross multiply here, won't that give me the PQ squared on the left-hand side? Okay, so maybe if you kind of multiply both sides here. So if I say multiply both sides by PT, I'll multiply both sides by PQ to get rid of the fractions. So over here, they'll cancel, and I get PQ squared. Suddenly feeling a lot better about my life now. Got a PQ squared here. On the right-hand side, the PQs will cancel. I get PR. The PQs will cancel. I get PR times PT. Not quite this here. Okay, but nearly. So maybe you can see the final piece of the puzzle now, the final step in the question. Look at that PR there, and look at your diagram. So if you look at the original diagram, PR. See it? So PR goes from here to here, to the very top. So see, PR is PT plus RT from your diagram. So that's what you got there. Sorry about that. Okay, this is the iPad's starting to get as tired as the rest of us are. Okay, but that's the final piece of the puzzle. Probably lost that calculation now, have I? Okay, so if I just replace PR there, as I said, with PT plus RT. Right, so because from the diagram I've got that, so PQ squared is equal to PT, this guy here, times PT plus RT. Because from your diagram there, PR is the same as that. I mean, when you multiply the brackets out, you get PQ squared is PT squared plus PT RT. Now, that's a really difficult question. And if you got one of that tomorrow, it'll be very poorly answered. All right? But the reason I'm just showing you that there is that when I see similar triangles, I mean, I don't know if you get one that difficult. When I see similar triangles, if you ask me to show that the two triangles are similar and then do something with it, I don't necessarily feel like I'm going to get full marks. I don't think I'm going to get 20 out of 20 on that because that's a very difficult question. But I'm thinking in my head the marking scheme. If I can identify any pair of angles that match and justify it, I'll get 7 out of 10 for that bit. If I can just identify two pairs of angles that match without explaining why in either case, I'll get 7. So I think maybe getting 7 out of 10 on the bit where you're asked to prove they're similar might be doable. And once I see the word similar, I would sketch what I did there. Sketch the two triangles and mark the corresponding sides with the same colour and write them as fractions. If you do that for part 2, you'll go and get 7 there. So I could get 14 out of 20 without necessarily being particularly good at that geometry, and then see what I can build from that point onwards. So you might get a question involving similar triangles tomorrow, I said, because he kind of emptied the options box otherwise last year. But it wouldn't shock me if he asked theorem 13 and then what goes on like that. So I don't think it's an absolute guarantee there's no theorem or construction tomorrow. I think it's unlikely, but there's no guarantee. I did want to say I wouldn't recommend, I think at this stage, going and learning them now if you haven't done so already. I think you can come up with a better use of your time this evening. So to finish up the handout then, we'll just have a quick look at the coordinate geometry, the line and circle, just to finish this up then, and that's all of paper 2. So I think we've had a look at everything there and given it a good old run. Right? So I'll do the circle first. Okay, the question that begins on page 24. Okay. Now, so question 24. Do not, under any circumstances, go in tomorrow morning if you're not able to find the centre and radius of a circle if you're given its equation. Okay, that is absolutely basic. So if you don't know that, that's something you go home and check tonight. Okay, that the formulas you need are on page 19. So it doesn't matter whether the formula is given to you in expanded form or general form, where the brackets have been multiplied out or not. Just make sure you know how to find the centre and radius of a circle. Okay, you just grab a formula from page 19, match it up to find what h, k, and r are, or what g, f, and c are, and then find the centre and radius. So there's usually like 10 marks up for grabs for just doing that. Right? So just be careful with C1 there. When you're pulling out the values of G, F, and C, remember to make sure that you bring everything onto the same side first. So C1 there will be x squared plus y squared minus 2x minus 2y minus 8 equals 0. Yeah? And then remember, you've got your formula on page 19. I won't do the whole thing out there, but you've got that formula there on page 19. X squared plus y squared plus 2gx plus 2fy plus c equals 0. And just by matching them up, you can see, compare these two to find G, F, and C. And then there are formulas on page 19 that tell you how to make up the centre and radius, right? So if you do that, for C1, the centre turns out to be M1, 1. And the radius is root 10. Okay, remember the formulas for doing that are on page 19 of your formula booklet. Okay, you're told the centre is minus G minus F. And the radius is the square root of G squared plus F squared minus C. That's all on page 19. So all that stuff there is on page 19. So you don't need to memorize that. So I grab those two. And then for C2, the centre is 13.5. And the radius is 3 root 10. Okay? Now, if you get a question like that tomorrow and you don't know how to find the centre and radius, I think not only does he give you no marks, he'll probably send out a couple of guys in shiny tracksuits to grab you on your doorstep afterwards and break your knees, all right? So you deserve more than just no marks, not being able to do that. That requires physical consequences, all right? So if you don't have to find the centre radius of a circle, go home and check that first. You're going to be doing it somewhere. It's 10 easy marks for doing next to nothing, so make sure you've got that in your toolkit. Okay, so I've got the centre and radius. Now, if you get this one here, okay, show that they touch externally, gift. Because there's almost nothing to do here. It's a very simple calculation, okay, to show that two circles touch externally. Remember, that means they've got a single point of contact. So all you've got to do, even look at your diagram here, right? If you remember that what we've got now is the centre of C1, that point there, okay, that point there is the point 1, 1, and that's root 10. That point there is 13.5, and that's 3 root 10. Right there, that's what I found in part 1. If the two circles touch externally, if I find the distance between the two center points using my distance formula, it should equal the 2 radii added together. That's what it means if two circles touch externally. The distance between the centers is equal to the 2 radii added together. Now that's a very simple calculation, because remember, your formula for getting the distance between 2 points is on page 18. It's one of the junior cert formulas, right? The one for finding the distance between 2 points. Okay? So it's that formula there. The square root of x2 minus x1 squared plus y2 minus y1 squared. It's on page 18. At higher level, you don't get marks for writing down the formula on its own when it's in the formula booklet. So I'm not going to reward you with marks for opening page 18 and copying down a formula, okay? But if you write the formula down and you successfully put any numbers in the right place, you'll get the low partial. So any kind of even partial substitution will get the marks. So if you just fill the two center points in, the square root of 13 minus 1 squared plus 5 minus 1 squared, and that comes out at 4 root 10. Can I just remind you, it's the same as I would have mentioned earlier on the very first question today. I would write that down, because if you just put the numbers in the formula and write down the correct 4 root 10, he'll give you full marks. If you make a mistake in the formula and write down the incorrect answer, he has to give you 0. So try and make sure you write down the formula substituted first so he knows you're doing it correctly, and then give him the answer. So if your answer is not correct, at least he knows you were doing it correctly, right? And then I'd also mention here that the sum of the radii, or the 2 radii added together, is 3 root 10 plus root 10, which is also 4 root 10. Okay? So make sure you lose a mark if you don't write your conclusion. Your ta-da, you have to flourish at the end, say, look, I did it. Okay, so mention that the distance between the centers is equal to the sum of the radii, or the 2 radii together. You don't need to use the word sum, but it's equal to the sum of the radii. Therefore, the circles touch externally. Remember, if you're asked to show something is true, that should be your last line. So show that the angle PQR is 90 degrees. You do your calculation, your last line should be, therefore, the angle PQR is 90 degrees. So you're asked to show something, it should be your final line. Right? And then the point of contact, do that with your, I would suggest, you can do it using simultaneous equations, of course you can. You can solve the equation simultaneously to find a point of contact, that's fine. It takes a little bit longer, but it's a full mark answer. For me, the quicker way of doing it is by using the formula for dividing a line segment in a given ratio. Okay? That if you look at the diagram as it's presented earlier on, okay, then when you're looking at the actual diagram itself, right? See that line segment there? Let me just remove this stuff for a second, just so we can see it a bit more clearly. Okay. So I'm dealing with the line segment now that goes between the two centers. Right? So if you imagine that line segment there, right? This point here is 13.5. That point there is 1,1. And there's the point you're looking for. That's root 10, and that's 3 root 10. So the point you're looking for divides the line segment between the centers in the ratio root 10 to 3 root 10. And you can leave it as root 10 to 3 root 10. The root 10s will cancel in your calculator anyway, or you can simplify it. The simplest whole number ratio is 1 to 3. You can divide both numbers by root 10. It's not wrong if you don't. Your calculator will cancel the root 10s, but the ratio there is 1 to 3. So to use the formula for dividing a line segment in a given ratio, all you're going to do is you multiply each point by the ratio number at the other end. So what that means is I'm going to multiply this point by that number, by the 3, and I'm going to multiply this point by that number, the 1. And then divide my answers by those two added together, 1 plus 3. So you multiply each point by the ratio. So for example, it's going to be 3 times that 1 plus 1 times that 13, and then divide your answer by 3 plus 1, which is 4. Okay, that's how you use that form. It's in your formula book as well, but you don't need to look it up if you don't want to. Okay, so I'm dealing with the x coordinates. Okay, so the x coordinates there, it's going to be 3 times 1, which is 3, plus 13 times 1, which is 13, all over 3 plus 1, which is 4. And the same with the y coordinates, then it's going to be 3 times 1, which is 3, plus 1 times 5, which is 5, again, all over 4. And that will simplify to what 16 over 4 is 4, and 8 over 4 is 2. So 4, 2 is the point you're looking for. That's P. So P is the point 4, 2. So touching circles, point of intersection, nice simple maths. Now, part 3. There's the 2 things just to finish off the circle questions here. Tangents and chords. So obviously finding the centre of a circle, center radius of a circle, we can all do that, or at least we should be able to do that. And this showing that circles touch is not too hard. Tangents and chords, right? The 2 things I would have on my radar when I'm dealing with tangents, because part 3 and part 4 will deal with both of these, okay, when you're told something's a tangent. The 2 things I would be thinking about first of all are, if a line is a tangent to a circle, right? You've got a circle like that, and a tangent here. If you find... I'm not going to lose my temper. I'm not going to throw a hissy fit and smash the whole thing and storm out of the hall, kick a cat or something on the way out the door. No, I'm going to be a grown-up, adult in the room. All right? So if you've got a circle here, and you've got a tangent, if I find the distance, see that there, the distance from the line to the centre of the circle, it should equal the radius. Remember, you've got that formula for getting the distance from a line to the centre of a circle. This formula here, from your formula booklet. The modulus of ax1 plus by1 plus c all over the square root of a squared plus b squared. That's the formula for getting the distance from a line to a point, right? So it'll tell me what the distance from that line there is to that point. Now, if that exactly equals the radius, the line's a tangent. If it's not equal to the radius, it means the line that misses the circle altogether or touches the circle twice. It's a secant line, okay? So if you see the word tangent, I'm thinking that straight away. If I find the distance from the line to the centre of the circle, using that formula there, put it equal to the radius, that's where my solution will come from, okay? So that's how I would always approach a tangent question here. So what have we got in the case of this one here? We're told, look, it's a tangent to the circle C1. I have the centre of C1, don't I? That's 1, 1. Found that earlier on. I have the radius as root 10. So what that means is if I find the distance from this line here to that point there, to make the line a tangent, it should equal the radius root 10. That's the equation I'm going to solve to find my value for k. And that'll always work. There are other ways of dealing with circles as well, but I mean, the only variable there is maybe it's the radius you're trying to find. You've got all the information on the line, you've got the equation of the centre, you're trying to find the radius. It doesn't make any difference. If you've got that fact in your head, if a line is a tangent to a circle, then the distance from that line to the centre of the circle using this formula is equal to the radius. That will always give you an equation you can solve for any circle question. So the moment I see the word tangent, I'm dialing into that formula there. So remember, A, B, and C come from the line. So A is whatever's in front of the x, so A is 1. B is what's in front of the y, B is k, and C is minus 8. There's A, B, and C. x1, y1 is the point, 1, 1. So let me just fill those in. So A times x1 is 1 times 1, which is 1, right? B times y1 is k times 1, which is k. Plus C is plus that minus 8 there, which is minus 8. All over the square root of A squared is 1 squared, which is 1. B squared is k squared, okay, like that. That should equal the radius, root 10. There's your equation that only contains k's. And, gentlemen, start your engines. Now, it's a little bit trickier to solve here, but it looks a lot worse than it is. But that's the equation. And certainly if you get that far, there's your high partial. But it'll always work there. But the key thing is to get A, B, and C from the line. A is whatever's in front of the x in the line. B is whatever's in front of the y in the line. And C is the constant in the line. x1, y1 is the centre of the circle. And put it equal to the radius and solve whatever you're left with, right? So you can see here, if I tidy up the modulus symbol there, I get the modulus of k minus 7 over the square root of 1 plus k squared equals root 10. Now, straight away, square both sides. We've got square roots in there, square both sides. Remember that I talked about on Thursday when we were talking about modulus equations. You can solve a modulus equation by squaring as well. So the modulus will not only deal with the square roots, it'll deal with the modulus as well, right? So I'm going to square both sides here. So obviously when I square the fraction, the square and square root will cancel. I just get 1 plus k squared below the line. That's no problem there. And when I square the root 10, I get 10. See it? So the two square roots just disappear. When you square it, they vanish. The question is what happens above the line. Well, remember, if you're squaring above the line, you've got this, right? It's basically the modulus of k minus 7 squared. Now, what does the modulus mean? Remember, the modulus just means if you get a negative answer, drop the minus sign. But when you square something, you can't get a negative answer. So what that means is when I square both sides, the modular symbol becomes irrelevant, and you can just rub it out. You can just ignore it. So it doesn't cancel with the square, it just becomes irrelevant. So I can rub that out there and just square k minus 7 as though it were a normal bracket. So this the modular symbol above down becomes irrelevant because you can't get a negative answer when you square. So just square k minus 7 like you would old school. So you get k squared minus 14k plus 49. If you square that bracket out old school, you get that. And now it's all over, isn't it? So if you multiply both sides by 1 plus k squared, just get a bog standard quadratic you can solve to find the value for k. So if I multiply this side by 1 plus k squared and this side by 1 plus k squared, they'll cancel. And you get k squared minus 14k plus 49. On the right-hand side, you just get 10 plus 10k squared. And now it's all over. Right? So just if I bring everything onto the same side, just one thing to notice here, can I just point one thing out to you here? Again, ask if would you have missed this? These are the little things that you missed. Do you see in the phrasing of the question? It said find the value of k. Singular, not values. And see what it said here? K is an integer. So what that suggests to me is we've got a quadratic here. They've normally got two solutions. I think one of them's going to be a fraction, one of them's not. So the value of k is the whole number. If I don't cross out the other one, I'll lose 1 mark. He said value of k, so there's only one. He's telling me it's the whole number value. So I think you're going to get a fraction here. It's not going to kill your score completely, but there's only one value for k here, and it's the whole number answer we're looking for. All right? So if you solve the equation you end up with, okay, down here. So I think the equation that we get is 9k squared. When I bring everything onto the same side, you get 9k squared plus 14k minus 39 equals 0. So if I open up two brackets there, I get 9k by k, or you can use your minus b formula. You're going to get 3 there, and I think you're going to get 13 there, and I think that's plus and that's minus. All right? So that's going to give you k is 13 over 9. That's the non-integer solution. Cross that one out. And that will give you k is minus 3, and that's your winner. So k is equal to minus 3 is your winner. But that's worth kind of pointing out. When you see the word tangent, think of that. Okay, so the distance from the line that is the tangent to the centre of the circle equals the radius. That will always give you a solution in a question of this type. Okay? Right. Now, part 4, the other thing to watch out for with a tangent. So when I see the word tangent, they're the two things I want to have on my radar. Okay, so when you see the word tangent in a question, think of that formula there, and look at the other thing I'll think of is what's mentioned here. Find the length of the chord the circle C2 cuts on the line L. Okay, and then we get down here to part 5. So there's the other tangent bit. Now maybe just look at part 5 first. Let's keep the tangent stuff together, because the word tangent is mentioned in here as well, right? So you can see in part 5, let O2 be the centre of the circle C2 as is marked here. Find the length of the tangents drawn from O2 to the circle C. So if I go from the centre of the bigger circle here to the smaller circle, find the length of that tangent there. See it? So once you see that you're dealing with that, the other thing that's true here, you've got a right angle. Remember, if I draw in this radius here, that's always a right angle. A radius and a tangent are always perpendicular. And that just gives me, does it not, a Pythagoras theorem question. See if I make that right angle triangle there? That's how you do that one. So you've got a right angle triangle there. You always will have. If you're trying to find the length of a tangent, there'll always be a right angle in there, because a tangent and a radius are always perpendicular. So you always get the right angle like that. And you can see it's good news here, isn't it? Because what's this side here? Well, it's not just the radius of C1. That's root 10. Yeah? What's that distance there? Because I've actually calculated that already, didn't I, back in part 2? Isn't that the distance between the two centres? That's 4 root 10. Yeah? And I just want to find this side out here, Pythagoras. So once I recognize the right, and again, once I draw in the right angle, there's my partial credits. I'm in business. All right? So I can just use Pythagoras, then 4 root 10 squared is equal to root 10 squared plus x squared. So that's 160 is equal to 10 plus x squared. 150 is equal to x squared. So x is the square root of 150, which your calculator will give you in its simplest form is 5 root 6. And that's your answer. So they're the two things to watch out for if I've got tangents on my radar. Okay, that the distance from the line that is the tangent, the centre of the circle, will equal the radius using that distance formula. And if there's any mention of lengths or distances here, that's right angle triangle. Okay, so the radius and the tangent will always form a right angle. That'll give you a right angle triangle you can use Pythagoras theorem on. That's where the solution will come from. And actually, to finish off the circle question, which will just leave us with the line question to do then, the chords will also deal with a right angle as well. When you see the word chord, dial into that. So what I'm trying to do here is when you deal with the circle for me is one of those topics, it's only usually a single short question. And that's what I think it'll be tomorrow. But it feels like there's page after page after page in my textbook with this here. Try to pare it down. So when I see the word tangent, it's going to be one of those two. Okay, I'm either going to use that formula, the distance from a line to the centre of the circle equals the radius using that formula, or I'm going to work with that right angle triangle there. That's what I'm thinking as soon as I see tangents. When I see chords, I always do it the same way. Okay, so part 4, we jumped over, when he mentions the word chord, okay, it says find the length of the chord the circle C2 cuts on the line L. So once you see the word chord, go back up to your diagram again, right, and then we just remove kind of some of the decoration here, because once I see the word chord, always, always, always the same thing. Right? So remember, we have the line L from a previous part of the question. It's x, remember it's x plus k. K was minus 3. So it's minus 3y plus 8 equals 0. So that's the line L. Remember that it was the x plus k minus 8, and we found the k was minus 3. So there's my line L there. And I'm trying to find the length of the chord that the circle C2 cuts on that line, right? So once I see the word chord, again, there's a right angle triangle, and all chord questions will work with this. Remember, if you go from the center point of the chord, it has to be from the very middle of the chord to the center, you make a right angle. That's one of your theorems, that a line drawn perpendicular to a chord to the center cuts the chord in half. Okay, but an easy way to think about that, if you go from the center point of the chord to the center of the circle, you create a right angle. So once again, we've got ourselves a right angle triangle, don't we? So you can see there's the radius of the bigger circle, which we worked out already was 3 root 10. So I have that side there, yeah? Do you see now to find, so I'm going to try and find this bit. Yeah, if I call that x, because I know that's going to be half the chord. Half because you must go from the center point of the chord to get the right angle. So you have to go from the center point of the chord to the center of the circle to get a right angle. So I know that's half the chord. Do you see the piece I'm missing is this bit here? And what's that bit? Well, look, the center of the circle is 13.5. Can't I use the distance from that line there to that point using my distance from point to a line formula to give me the third side of the triangle? And it's all over. So again, if I just say, look, I know what the equation of the line is. It's x minus 3y plus 8. I know the center point is 13.5. If I use my formula to get the distance from a point to a line, it'll tell me what that distance there is, and I've got the second side of the right angle triangle. But the key thing here is, if you draw that right angle triangle, everything you do is going to be moving you towards the right solution and picking you up marks. You're not heading in the wrong direction there. Okay? And if you're focusing all your attention trying to find that, it's much more likely you'll spot it. Right? So I want to find the distance from this line here to that point. That will give me kind of the little blue side here. Right? So again, remember, it's the modulus of ax1. Remember, a, b, and c come to the line. So a is 1. B is minus 3, and C is minus 8. That's a minus 8 there, not a plus 8, sorry. It's a minus 8, isn't it? Yeah, all right. So that's A, B, and C, and x1, y1 is the point. So A times x1 is 1 times 13, which is 13. Plus B times y1 is minus 3 times 5, which is minus 15. Plus C is minus 8. All over. The square root of A squared is 1 squared, which is 1. Plus b squared is minus 3, which is 9. And that's all numbers. You can pop that right into your calculator to tell you that's root 10. So I'm not putting that equal to root 10, I'm just putting it to my calculator to tell me it is equal to root 10. All right? So that little blue side there is root 10. And now, once again, I'll just use Pythagoras theorem on that triangle, and I've got the chord length, or half the chord length, which I can then double. So the circle is one of those very kind of bitty topics where it feels like there's an awful lot. That's why I'm trying to pare it back. So if I'm trying to prepare for the circle, the stuff that comes up year after year, there's always kind of little bits and pieces. Remember, you can't prepare for everything. The examiner is going to ask you a question that you haven't seen the like of before. He has to. He can't say, look, every question you're going to see, you've seen before. But I can practice a lot of it. So a lot of this kind of stuff I can practice. So touching circles, how I show the two circles touch. Tangents, one of those two things we're talking about there. And when I'm working with chords, it looks like this. So now, if I'll just kind of finish the calculation out, then we'll just very quickly look at the line, bring us up to the end of the class. Okay? So my calculation then, if I apply Pythagoras' theorem to that triangle there to find x, okay? So what I get there is 3 root 10 squared equals root 10 squared plus x squared. So 90 is equal to 10 plus x squared. X equals 80. Or sorry, x squared equals 80, which means x is root 80, which is 4 root 5. And then remember, that's half the chord. Remember, the right angle triangle is made up of the half the chord as one side, so then the full length of the chord is just double that. And that's what I think, that's the best you can kind of do getting ready for circles. Okay, that's the typical stuff I should be familiar with. Chords, tangents, touching circles, and how to find the center and radius. It's the kind of the best you can do to have your kind of toolkit for the circle intact. Right, so last kind of 10 minutes then, just so we kind of bang on time. We'll just have a quick look at the line. Now, the line for me is one of those, I'd never trust the line. Right, so sometimes you go back to the past example and you say, the line's going to be my friend, the line's going to get me out of trouble, and then suddenly it doesn't. Okay, so the line is one of those things where, you know, if you come outside a nightclub at 2 o'clock in the morning and something's going to kick off, you look over your shoulder, where's the line gone? Okay, the circle will be there, will have your back. The line's in a taxi, passing you here, all right? So the line might be there for you, might not. So I'm not going in there banking on the line. You can't kind of say, look, I'm going to leave out geometry altogether because the line will help me out. Not always. The line sometimes is ludicrously easy. The line sometimes is grotesque. All right? So it's one of those things that's kind of hard to. The best you can do is just make sure I know what my tools are, and I'll see if I can make some kind of a stab at the question when it comes up, right? So our last question then is the question on the line, and we'll just go up to that one there. Sorry, go down to that one there. It's question 10. Okay, so here we go. So question 10 then is coordinate geometry of the line, the only thing from paper 2 we haven't looked at this morning, right? So it says we've got two lines then. L1 is 3x minus y equals 4, and L2 is x plus 2y equals minus 1. So the two lines they're both given and labelled on the diagram, shown the diagram below. We're asked to find the measure of theta, the acute angle between the two lines, correct to 1 decimal place. Okay, so we're asked to find the angle between the two lines. So remember, there's a formula for that on page 19. Okay, so the formula there on page 19, right? So it's tan theta. It's m1 minus m2 over 1 plus m1 m2. Now, in the formula book, there's a plus or minus here. I don't need that when I'm doing basic calculations. All right, I only need that if I was asked if I was kind of told what the angle was. I'm trying to work backwards to find what the slope is, because there's two possible angles. I could go maybe 70 degrees left or 70 degrees right. There's two possible angles. But I'm just trying to find an answer. I don't need the plus or minus. So I'm not going to worry about that at all. All I need is the slope of the two lines. Right, that's what this question says here. So can you find the slope of the line 3x minus y equals 4? Well, remember, to get the slope of any line here, just minus a over b. As always, a is what's in front of the x, b is what's in front of the y, c is the constant. So minus a over b. So in this case here, so that's a and that's b. So the slope of that one there is minus a over b. It's minus 3 over minus 1, because a is 3 and b is minus 1. That's just 3. And for the other line then, which is x plus 2y equals minus 1, a is 1 and b is 2. So the slope is minus a over b, minus 1 over 2, minus a half. Now, you can, of course, do that by rearranging the equation. You know that one where you write it in the form y equals mx plus c. You get the y by itself on one side, the equal sign. And then whatever's in front of the x on the other side is your slope. That's fine. Yeah, there's options here. But just make sure you know to get the slope of a line when you're given it like that. You will get people, I mean, I've seen people do that where I try and find 2 points in the line and use the slope formula. That's fine. You'll get the right answer around the same time you hit menopause. It takes a lot of time. But it's not wrong. The key thing is you get full marks. It doesn't matter how long it takes me to get there. All right, so the quick way is minus a over b, and then just throw them into the formula. Okay, so if I just pop those numbers into the formula then, job's done. Okay, so if I just say that means that tan theta, m1 minus m2 is 3 minus a half over 1 plus m1, 3 times minus a half, like that. And if you put that into your calculator, you're going to get the number minus 7. Now you can ignore the minus sign, because if I ignore the minus sign, I'll get the acute angle. The minus sign will give me the positive, sorry, the obtuse one. It doesn't make any difference. Okay, you can put the minus sign or you can leave it out. It doesn't make any difference. I'm going to leave the minus sign out because it'll give me the acute angle. So that means that theta is just the inverse tan of 7. Okay, and that comes out, it's like 81.9 degrees. That's to one decimal place, so 81.9 degrees. And again, that looks right in the diagram. Just remember, don't trust the diagrams necessarily. That it's a standard understanding on Leaving Cert papers that diagrams do not have to be drawn accurately or to scale. But to give you information, they don't have to be drawn accurately, so it doesn't have to be an exact 82-degree angle in there, but that's the angle. So that's just going forwards, finding the angle that you're looking for. All right? Now, part 2, the question's quite easy, probably only worth 5 marks. So if you look at part 2 of the question then, again, just the language. It says, see that if L1 intersection L2 equals P, it just means the point of intersection. If you're looking at that saying, I don't understand the language, look at your diagram. So I'm having a Scooby what that language means. L1 intersection L2 equals P. Look where P is in the diagram. P is the point where the 2 lines intersect. See it? So you're trying to find the point of intersection there, and you should have superglued together in your head simultaneous equations of point of intersection. Anytime you want to find points of intersection, you solve simultaneous equations. Anytime you solve simultaneous equations, what you're doing is finding points of intersection. So you've got 2 simple, just solve those 2 equations simultaneously. I won't kind of dwell on that. That's quite easy to do. It's just a pair of linear equations to be solved simultaneously, okay, to find your value of, to find the point P. So I've kind of done it out for you, the solutions anyway, but P ends up being 1 minus 1. That's just simultaneous equations. No real problem there. Now, Q, it says Q is the point 5K, where Q is an element of L1. It's on the line L1, right? So we're told, and see again in the line here, he's kind of giving you some easy bits to ease you in. Little 5 markers that aren't too bad. Remember, if a point is on the line, it means if you put this in for x and y in the equation of the line becomes true, or the statement becomes true. So the equation for L1 is 3x minus y is equal to 4. So put 5 in for x and put k in for y. You get 3 times 5 minus k is equal to 4. So that's what minus k is equal to minus 11. So k is 11. Okay, so the point Q is 5, 11. Just subbing 5k into the formula. Now, last 2 bits then very quickly, just to bring us up to the end. Okay, now it gets a little bit trickier. So part 4 says, OR is a point such that Q divides P OR internally in the ratio 2 to 1. Find the coordinates of OR. Now, the internal divisor, that's the one where a lot of books get you start changing the signs in the formula from the formula booklet. I don't like that method. It's also, you'd also use the internal divisor if you're dealing with 2 circles that touch internally rather than externally. Okay? The better way of doing that is to use your diagram. If you look at the diagram up here, right? So look at the points as I've got them at the moment, right? I know that P is the point 1 minus 1. Found that already. I know that Q is the point 5, 11. And I'm asked to find this point up here, or just call it xy. Right? I'm trying to find that one. Now, I'm told it divides the line segment with the ratio 2 to 1. So that's 2 to 1 like that. So if I use the formula the same way I did when we were dealing with the touching circles, remember I multiply each point by the ratio number at the other end. So in other words, what I'm going to do here is I'm going to multiply this point by that number. I'm going to multiply this point by that number and divide my answers by 3, the 2 of these guys added together. So if you just look at the x coordinate for a second, I'll just do it here rather than kind of going down to the box there. But look at the x coordinates, right? So it's 2 times x, which is 2x, right? And 1 times 1, which is plus 1. And then I'll divide that by 1 plus 2, which is 3. And don't I know what that answer should be? That should give me 5. Yeah, the x-coordinate of the point, the divisor point, which I already know. Okay, so I'll put that equal to 5 and solve. That for me is a better way of doing that one when you're dealing with the external or the internal divisor. Call the point of one end x, y, and treat it the very same way, right? So multiply both sides by 3 there. I get 2x plus 1 is equal to 15. So 2x is 14. So x is 7. And the same for the y coordinates then. So I multiply this y coordinate by 2, so I get 2y. Multiply this x coordinate by 1, so 1 times 1 is minus 1. Again, divided by 3, and that should give me this 11 here, the 11 of the divisor point, which I know. So multiply across by 3, I get 2y minus 1 is 33. So 2y is 34. So y is 17. And there's the point, or it's 7, 17. Okay, see, that's a bit trickier then, the line kind of turning on you. And then because it's literally the only coordinate geometry formula we haven't looked at, just a lovely place to finish up with. The last part of the question then, okay, here's the kind of the tricky bit. A few bits and pieces of moving parts in this one. But it does mean that we have actually touched base with every topic on paper 2 today. We kind of all the short, all the long questions, what's most likely across them. So I mean, at least it's refreshing your memory on a lot of the stuff that's going to make an appearance tomorrow, without kind of going down the route of predictions. Just here's the basics that we should have in every topic here and how it's likely to be examined tomorrow. So it says S is a point such that S is on the line L2. It's in the second quadrant. Remember, so the second quadrant is this one up here. Okay, where x coordinates are negative and y coordinates are positive. That's the second quadrant, yeah? And the area of the triangle, okay, so it's an area of a triangle question, P or S, is 126 units. Now, we know what P is already, right? So we have P is 1 minus 1, right? We know what OR is, we just found it. It was 717, right? So I have those two questions already. The question is, what's S? Because what we're told is S is on the line L2. So look at the equation of the line L2. L2 is that equation there. It's x plus 2y equals minus 1. I think if he gave you this, he'd maybe give you a prompt to push you in the right direction here. But if you rearrange that, let's say we get the letter x by itself here, right? So I leave the x by itself here. I get x equals minus 2y minus 1. That means for every point on that line, the x-coordinate is minus 2y minus 1. So I can write that point there as minus 2y minus 1, y. Now, that's the part I think that people would struggle with. So let's say you weren't able to do that. Okay, it means I'm probably not going to be able to finish the question. I don't have a point down here. Let me show them all the other bits and get my 7 out of 10. Right? So there's my 3 points there, and I'm told the area is 126. Remember, you've got a formula for getting the area of a triangle in your formula book on page 18. It's the half the modulus of x1, y2 minus x2, y1. You can only use that formula when one of the corner points is 0, 0. So straight away I see an opportunity to get some marks here. Let me show them I know that, and I do that much. So just pick whichever point you like and move it to 0, 0. Now, for any of you who would kind of say, look, I do that there, and I would have moved S to 0, 0. That's an entirely self-inflicted injury. When that goes to shit, which it'll happen very, very quickly, that was all you. Don't come about saying the examiner asked a really difficult question. No, no. The examiner asked a reasonable question. You turned it into something hideous. Okay? So what I did there was, remember, I subtracted 1 from the x-coordinate, and I added 1 to the y-coordinate. That's the translation that moved P to 0, 0. So do the same thing to the other 2 points then. So, subtract 1 from x, so this gives me a 6, and add 1, I get 6, 18. And then subtract 1, I get minus 2y minus 2. And add 1, I get y plus 1. Now, even if I didn't have that bottom point there, just showing I know to move a point to 0, 0, and I was able to do it for the ones that are numbers, there's my partial credits. I'm not getting 0. All right? And now, if I put these 2 points into my area formula, put it equal to 126 and solve, I'll get my value for y. Right? So a half the modulus of x1, y2, just multiply these 2 together first. So 6 times y is 6y, and 6 times 1 is 6. So you multiply these 2 together first, minus, multiply these 2 together. So 18 by minus 2y is minus 32y, sorry, minus 36y. And 18 by minus 2 is minus 36. There we go. So it's a half the modulus of there's 6y there, and then minus, that's what, 42y, I think, because it's minus 36, that's plus 36, and then 6 minus 36, that's plus 42, equals 126. Mission accomplished. So if I multiply across by 2 to move the half, I'll get the modulus of 42y plus 42 is equal to 254. That's just multiplying both sides by 2 here to move the half. Right? And now remember how you solve a modulus equation? You can square both sides, or because this is an easy one, where if you've got a modulus equals a number, I can take whatever's inside the symbol here and put it equal to plus the right-hand side and minus the right-hand side. So I can say, look, 42y plus 42 is equal to 254, or else 42y plus 42 is equal to minus 254. That's the shortcut for solving a modulus equation. If it's just a modulus equals a number, put what's inside the symbol equal to the right-hand side and minus the right-hand side, right? Now, if you do that, I think you get y equals 5 here, and you get y equals minus 7 there, right? So 5 and minus 7 like that. And remember, it said find the coordinates of S. That's why he told me that S is in the second quadrant. So the second quadrant is this quadrant up here where y values are positive. So the y value can't be minus 7. It has to be y equal to 5. Again, it's not a huge penalty, but I will be penalized if I don't cross that out. And then to find the matching x value, just put that y equal to 5 back in here, right? And you get minus 11. So minus 11.5 is the point there, and that's what the line may end up looking like. Now, that's all of paper 2, right? That's a quick look at everything on paper 2. So if nothing else, it's kind of put it all back on your radar before you get the paper tomorrow. I've already given you kind of guidance on how to approach the paper. But the key thing is, don't worry about what happened on Friday. Okay, as I said, in probably 7 or 10 cases, you've done better on paper 2 than paper 1 than you think you did. The same will happen tomorrow. You'll come out, you kind of think you've done less well on paper 2 than you probably have done. Okay, so don't give it any worry at all. Okay, just get stuck in, give it the same approach you did the other one, and the very best of luck. Okay, I hope it goes well for you.